Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and first of all, a massive shout out to the several hundred people that have subscribed to this channel in the last month. But if you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live, so toss me a buck or two in there if you've been enjoying these live streams, but most importantly, if you would like to join the debate, there is a link in the info box below this video. With the page you are currently watching on mute, simply click that link to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin the stream using stock accounts. You will be warmly welcomed back on the next stream. In a moment, I'm going to transition across to my photographs so I can share the show on Facebook, Skype and Twitter. And I would encourage anybody who is currently in the live audience to please also share the show. Sharing the show, of course, increases the live audience, which in turn increases the chances of a more diverse panel. So please, please, please share the show. And one last time, a big shout to all the several hundred subscribers that have recently subscribed to this channel, but if you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. So I've just shared the show on Facebook, Skype and Twitter, and one more time I would encourage anybody who is in the live audience to please also share the show. I'm going to run through this for the people who've just joined us live, but if you are new to this channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. And if you would like to support this channel, there is a super chat that runs alongside the show while it is live. I'm going to rush through these links if we have been joined by our first guest. So let's transition across to the show and raise the mic on the Hangout. We've been joined by Make4. How you doing, Make4?
It's always me. How you going?
Good to see you, my friend. Thanks for being here.
Yes, I have been drinking.
Is that so?
Well, it's, what is it, Friday night here, I think? I think it's Friday, yeah. It's a good start to the show. Some drunk guy coming in to...
All are welcome.
So, what's on the cards? Where's Riley?
I don't know. He doesn't immediately turn up all the time. He's not curved water.
Because, yeah, I'm still having the old... Well, you know, I figured out the whole spherical sky thing, but I don't know. It's weird here. It's definitely weird on the ground and in planes. I don't know if it's just so massive that it looks flat, but I don't know. It's hard to see curve, that's for sure.
Yeah, you may not hear much from me because my kid's got a recorder. So
that's cool.
She's making quite a lot of noise.
What's up with that? Why do they always make us learn recorder in school? Like,
I don't know. I think she's playing Jingle Bells on it though.
Nice.
At least trying. Yes, thank you. Thank you. Very useful. But yesterday they had a debate about the stars being visible outside the atmosphere. And I've got to be honest, I was pretty knackered yesterday, so I didn't interject too much. And that and my mic was broken in the Hangout. Worked for the audience, but not for the people in the Hangout so much. But I didn't get the opportunity, therefore, to say, well, who of us are verifying this? Who of us are going outside the atmosphere to see if we can see the stars or not? It's all pie in the sky,
Yeah.
meaningless nonsense. But what we can
See,
see down here on the ground, as you pointed out, is a lot of flat observations. You know, people seeing things that they shouldn't normally be able to see. And typically, they've co-opted refraction and put it in place of curvature. So normally when we see the bottoms of a building obscured, they go, there you go, that's a bit of refraction obscuring the bottom of the building. You know, that's curvature. That's what you're seeing. But in reality, it's just refraction. That's all we ever get to see. And in the case of Anthony Riley's most recent presentations of the Isle of Man, we've got something far, far worse, which is, you know, we've still got in some parts of the photograph a little bit of this atmospheric distortion at the bottom of the island. The problem is the whole damn thing shouldn't be seen, and even their bullshit refraction maths that they've added onto the curve calculation doesn't account for it. The only place they can go from that is to say that we're not really seeing it and it's a mirage. But the problem on top of that is that because we're seeing this island that's ever increasing distances away from us, yes, on a 2D presentation it just looks like an island that's left to right, but in reality the far end, the left hand side of the picture, is considerably further away, therefore would be considerably further over the curve. So in terms of accounting for it with mathematics and saying it's non-standard refraction, the maths equation's getting ever more complicated because you're going to have to bring something back that's 50 miles away from beyond the curve rather than the closer part of the island. And it gets even worse because the closest part of the island seems to have the only bit of what they call curvature refraction, blocking the view of the initial part of the island. But as I say, that's the closest part. So the only explanation is that we've got this ever-increasing refractive band that's creating this mirage that is not only perfect in its appearance and makes a perfect scale representation, it's doing this with ever-increasing degrees of non-standard refraction, bringing it back from the ever-increasing curve as it goes over and gets further away from us. To say that this thing is not just on a flat plane and we're just seeing it because it's a clear day is ridiculous. It's getting ever and ever more crazy in terms of the explanations they're going to have to give us for this item, as I say, that gets further away.
Yeah, well, I want to respond to that, but just want to say g'day to Sleeping Warrior and Psychics.
Yeah, good day, physics and sleeping. Sorry, caught me on a rant.
Morning, Jen.
Good day, everybody.
Hello, hello.
I was gonna say, like, yeah, okay, so this whole thing is really confusing the calculation of the curvature and like how that's done. Like I would like to, I still haven't bothered to look into this calculation. Like really, I don't, to be honest, I don't I've never bothered to go that far with my maths into trigonometry. So yes, hate on me, but I would like to know like the actual calculation, and also some other things I'd like to say, which was about seeing the stars when you like look at interviews with astronauts and stuff. Some of them say yes, I saw them. Some of them say no, I didn't. And the original one with Buzz and stuff, they said no, we didn't see them. But what's weird with me at the moment is like, even though I have personally calculated like by looking at my own stars down here in the sun, and I've sort of found that it's spherical in nature, like when I look at the Milky Way and stuff, it doesn't, and the constellations that never change, like it doesn't feel like it should like it's actually a solar system dealio.
Can I just address one thing? Just one thing, which is that you said that the astronauts gave differing accounts. Well, that's from the moon's surface. Whereas in terms of could they see the stars outside the atmosphere? Absolutely. You know, I found NASA footage of them using the stars to navigate to the moon. So they absolutely had star charts. They could see the stars. They used them to navigate. That's undisputed. But from the surface of the moon, that's where it gets contentious. I don't think they ever visited the moon. I don't think they ever left Earth's atmosphere. I think it's all nonsense, but I'm just putting it out there as that's actually how it stacks up.
See, then you get the people, like there's been a lot of astronauts just slip it out there, like, oh, well, you know, we're working towards going out of lower Earth orbit sort of thing. And it's like, what the hell? Hold up, what?
Yeah, they're doing that to tell the kids of today that we'd not been to the moon. That's what really they do.
It's like a sneaky change up, but...
No, it's called deceit.
See, it's weird because, like, you know, like the things that Grimm talks about, which is such as the equinox, where he's talking about if you really do map out the sun and its direction, the only possible model is really like a globe model, unless you have this.
Yeah, but make four. Listen to this. Grimm makes the claim that the vernal equinox proves the ball Earth. Does it actually prove the ball Earth? That's the question you have to ask. If
Sorry,
you
what claim?
The vernal,
the shape.
You're on about Grimm's claim that the vernal
equinox, right? Yeah. Well, but so what would be the because the sun? That's what sort of sparked me and got me back to the ball side. Because I would like after I figured the sun rising and setting, you know, north or south of those east and west points, like it just flipped me. It's because on the flat, if I don't know.
Well, there's two things with the vernal equinox. Firstly, if the claim that the vernal equinox proves that it's a ball Earth is actually true, then that's relatively strong evidence because I can see why it makes logical sense and it's flat Earth debunked to some degree. However, it makes the assumption that the sun is something that is a big tangible ball of liquid fused helium, hydrogen, whatever they want to call it, a big ball, a three-dimensional ball in the sky. It isn't. So don't necessarily look to the vernal equinox. Look to what the sun is. Research the sun. It's not what they tell you it is.
Yeah, see, that's
how
the
does
thing.
It debunk on a flat map?
What?
How does it debunk on a flat map since if the sun is spinning around around the circuit on a flat plane?
Well, the thing, if you look at the degrees, like with a compass of where the sun rises and sets, then like on a flat map, then the sun would be like wobbling kind of thing, like because it rises south of east at the moment because the southern hemisphere is getting summer, so the south end is pointing towards the sun. It when the rise happens, it's a bit below east, south of east, and then when the sunset happens, it's below west, southwest, 240 degrees, and that's like the same for all over the world. Like it'll be those same angles.
It's an angle, yeah.
Yeah, and I mean it's sort of.
But the angles doesn't tell me if it's round or it's flat. It's an angle.
Yeah. But anyway, let me get back to the point of even though I've done this and I've mapped this out on a globe and I've kind of seen like the globe model makes a little bit more sense, even though the moon's off by like 5 degrees and fucking like we're on this axis somehow, and that never really changes. If it does, you don't feel it. And the stars that you would see wobbling because of your axis shift, as you go around the orbit, you'd be, the stars do wobble. Apparently they do, and fucking it's minuscule. Sorry, yes, swearing again. Excuse me. I've been chatting all day to people and swearing, so I got to get back to no swearing. But and the constellations never changing. We just drift around in the galaxy the same position, and we have our little orbit area that doesn't really change or move, and we circle that perfectly inside the big circle, and then inside that circle there's us rotating with another moon going around it in another little. We've got our own little space. Like, fuck. Excuse me. That's a lot of little spinning going on there. And somehow it maintains control and just keeps us perfectly there, all balanced out. Yep.
Well, I want to go back to refraction. We've been going on with this for about a couple of days already, and nobody's on the other side has figured out exactly how the refraction works, or even tried to do a simple experiment. I even posted a link on the chat down there just to see how the sun travels away from you. And it gives the same exact perspective as if you're looking at it. You could even take a picture of the Chicago skyline. It will show the same exact exposure where the bottom is missing and the top is exposed on a flat plane.
Of the sun, did you say? Sorry.
Wait, how it travels. So if you were to take a refraction glass and put it on a flat table, put it in the middle, you could take a lighter, or you could take a picture of a sun, and you could put it towards you or away towards away from it, and it will give the same exact perspective as if you're looking at the sun moving away from you. It's ecliptic.
Right.
It's the same exact observable view. If we could do this on a flat table, it should be no different as above. So it's doing the same exact movement.
Right. Well, because
now
I have
with
these
this
mountains.
big art,
Sorry, you go. Keep going.
go ahead.
So
With
I've got
this
these
argument,
mountains.
we have a lag check going on. But anyways, but with this argument, we've been arguing about this even before camera. I mean, 3 miles long, people thought it was actually there is a curvature above that refraction 3 miles with our own perspective. But now, since we have these P900s with an 83 zoom, we're actually doing the same exact argument. The curvature is beyond the refraction. It's above, it's high, it's below. It's still doing the same thing until we get another 100%. Until we come up with another camera, it's 100 zoom. 100
Yeah,
times
that's
zoom.
what I was thinking. And
It's just going to be the same exact argument till everybody
I
gets
don't know,
on board and
physics.
sees exactly how the refraction works.
you need
This is
to
a
get a
different
camera that's got a
situation
better
now.
zoom than that P900 and do it to that lighthouse and see if you can get the ground of that lighthouse or something like.
You have. I mean, I think it's a different situation with the current photographs because of a very specific situation which hasn't arisen, which normally does. So if you take the Chicago skyline, you get certain photographs that show it with a bit of atmospheric refraction, and the globers will say that's the curve. There it is. You can see it. It's obscuring the bottom of the building. Now, as I said earlier at the beginning of the show, we still have that effect in the photos that we're talking about, but we're so far beyond where you can insert that as curvature that it becomes farcical to try and do so. What we have is huge amounts of the land that are visible that shouldn't be, far more than they can ever account for with their standard, in quotes, maths. So we have Gish Gallop and ad hoc, and this is how the maths was made, and this is how we can vary it, and they have to start inserting variables into their standard maths that we've seen 100 times when we see things like the Chicago skyline with what they call curve in front of it. Well, there is no curve in front of it. We always see atmospheric refraction. We see it more if we're looking further, but there's no curve blocking that view. None. And there's no way there's any maths that's going to tell me otherwise when it's going further over the curve at the left-hand side of that island. It's considerably further away. So the maths to do it is going to be so horrendously complicated to convince me that it comes back into view in perfect proportion as it gets further away from our viewing point. It's nonsense. You just can't bring it back with maths. Not in perfect proportion. Not without an equation that was an entire paper long, like 25, 30 pages long of maths to show as it goes up that line of coast, how we have the most amazing situation ever where it's bringing it back at varying degrees as it goes over the curve. It's just nonsense.
Sure.
Been joined by Arav. How you doing, Arav?
Hey, Arav. There was also another experiment that they've done with several people did the sun tracking, and they measured it and they angled it as well. Now, my question is that are they using the math as far as 93 million miles away with the sun to get that calculation and those angles? Or is it they're using this, what math are they using to get the triangulation for each person from different areas?
There's a presupposition that you have to insert into the mathematics to make it work on a sphere. So if you take the measurements, you then have to account for the fact that you are sat on a sphere when you do the trigonometry. So it's two different types of trigonometry.
Oh, that's why it didn't work out the first time, and that's why it showed different variances. Okay, I get it.
I think it's Tycho Brahe's elliptical orbit theories, assuming that we're spinning around the sun. And I think they take their size calculations from that, the Copernican principle. Everything the globers do, they put through that Copernican principle. Anything that goes against that paradigm, they throw out, and they're highly biased against anything that's not heliocentric and based off of a ball model.
And then with another caveat, which is Mick Bunk's, Meta Bunk's math.
So it's like we're going to have to look at these guys' theories and just look at these holes that are in them. These equations are just based off of nonsense.
Yeah, honestly, we could just chill and have beers and just wait for a better P900.
Definitely.
or compare the two cameras together. The two photos with two different cameras.
Yeah, get a telescope. Like, what's the deal with not being able to get like a super powerful telescope that lets me see Saturn clearer than what I can see it? Why can't I get one of
You
those?
have to go through.
I'm talking like,
It might be the water. The water's above or kind of blocking the rays, probably.
You can make 4. You can get a better view. You have to get above the atmospheric refraction. That's why we have places like Keck above the clouds.
Or Sophia.
Or
Infrared.
Sophia, that's another good example. Same principle.
And how would refraction even...
Hey guys, I'm
I mean,
gonna take off. I just want to get a couple things in.
It's been a pleasure, Physics. Thanks for being here.
Welcome. Bye, Nathan. Bye, Make4. Bye, Aroth. Bye,
See you,
Warren.
mate. So yeah, the whole spherical sky thing is kind of killing me for the whole flat Earth theory. But I will say the footage I see, the photos I see, they just make me second guess and go, it's pretty flat looking. It's pretty weird looking. Like when you get up in some of those weather balloon videos, there's no stars or anything. It is middle of the day, but when it gets up there, it looks so weird. It's like
Looks like you're looking through water, doesn't it? Like the water's above versus the water's below, perhaps?
I don't know, but I've seen a few and they seem to like top out at the same level. Like they can't go past 120,000 feet or something like that, which is really weird. I think it's about 33 kilometers or something. I don't know. It's kind of weird.
Yeah, you see the videos of the rocket hitting the dome about 70 miles up. So I guess it will touch down.
I've heard someone try to explain that was because of the rockets have some special wings on them that pop out as it goes up and it stops it or something like that. And they said that's what happened. But I don't believe that. Oh, I don't know if that's true.
I can help you on that one. Brian Mullen Brian Mullen suggested that it might be hitting something, and he reconsidered his position when someone told him it was called the yo-yo anti-spin device. And what it is it's 3 or 4 weighted explosions that throw weights out to stop it from spinning. And it is, you can hear it. If you listen to the sound, you can hear it literally go poing. It's like it's an explosion. It's a small pyrotechnic explosion that deploys weight to stop it from spinning. And it does exactly what it says on the tin.
But see, I've seen those rocket things, and one dude has an altitude meter on it, altimeter or whatever the frig, and you see as it makes that noise and sort of starts spinning, you see his altitude like literally stops dead on, like straight away.
Oh, I don't know. I've not noticed that.
Have you seen that one? That one's weird.
No, I haven't seen that. I've just seen the yo. It's called the yo-yo D-spin device, I believe, or something very similar to that. Come on, Paul Voigt. We know you're out there. You were in chat 2 minutes ago. I'll tell you what I can do. If I share my screen, what we've done to try and, or what Ranty did yesterday to try and help people with what curvature should or should not be seen. What Ranty did was he made this line, and the line is representing the actual the curvature of the Earth that we should be seeing. Now, because I'm looking, this is kind of like right in front of me almost. Maybe it's a little bit to my right. But as I'm looking, at some point, somewhere around about here, I'm looking straight in front of me. But then at some point, I start to tip away to my left. And as you go further left, it starts to tip further away. So it's supposed to get, well, it's supposed to dip away exponentially the further away we look. So yesterday's chat was Jeremy, and Jeremy pointed out quite well, I thought, that he thinks that this is a particular lighthouse. And I agree. Towards the end of the hangout yesterday, Ranty said that it wasn't because reasons. We've flipped back now to agreeing that it is that. So Jeremy did get the correct lighthouse. notwithstanding the fact, of course, that all of it should be behind the curvature, Jeremy wanted to know why it was that we weren't seeing the very bottom of the lighthouse. So if we zoom into the main picture, I mean, despite the fact that all of it should be behind the curve, Ranty's in work today, so he's not able to be here, but he sent me some pictures, and I'll just bring some of the pictures up.
See, this is the thing, man. Like, and the curve calculations changed in the last how many years, hasn't it? Like it wasn't right before or something. I feel like it's just not happening.
Yeah. Well.
Yeah.
Well, what I'm going to try and do is.
And part of it.
Go on.
Is there two of them? No, wait, what? That's
no.
Photo.
This is a picture of the lighthouse location that Jem spotted. And what Jeremy's asking is, why is there not enough land beneath the lighthouse? And our position is now this. All of the land is there, and we're seeing all the way down to the waterline. Literally, you can see the waves, and I'll show you in a sec. You need to notice that there's this white blob. The lighthouse stands on a small platform, and then there's a blob part of it that's giving it depth that isn't actually part of the lighthouse, but it makes it look longer. But if you account for that in the most that we see in the image, and then you can put another lighthouse back in, and that takes you pretty much down to the water level. Okay, so we're looking for double the height. Now, I'll come back to the picture in a sec. I just want to go.
I don't know if that's a great way of measuring it, but okay.
Well, just bear with me 1 sec. So I've got a call coming through. I'll have to hold that thought for a sec.
Just like, yeah, the red line is enough for me to go, if that's what the calculation should be, then that's all we need. If you can see that damn lighthouse at all, then that's enough, isn't it? Like,
this is the point I tried to get through to Lewis Hackett, but he was too dumb to understand. So he's like, why don't we see all the way to the beach? It's like, you dumb idiot. We shouldn't see any of it.
It's just like,
none of it should be there.
The thing is, like, I wasn't paying attention. What was it? 50? Is it 50 miles or 50 kilometers?
The furthest point of the island that we can see is 50 miles. Now, this is also a bone of contention, which I will drop in here. It is my assertion that it's Ireland that we are seeing in the far left-hand side of this image that we'll see in a moment when Anthony Riley gets back to the mouse. But what I contest we're seeing is Ireland. However, we've only got two choices of what we can see on the far left of this image. It's either the extreme edge of the Isle of Man, which is 20 metres above sea level, or it's Ireland. Those are the only two choices. It can't be anything else because there's nothing else in the line of sight. So, lesser of two evils, Paul, the physicist, conceded that, and we conceded, with his assertion that it's Ireland. The Isle of Man. And therefore we are seeing at 50 miles land with a 20-metre elevation. Again, because it's further along the island to the left, it is much further away from our vantage point. Therefore, you'll see in a moment as this photograph progresses to the left, it should be even further behind the curve. And as you all know, it's an exponential calculation. So this gets worse for the ballers as we get further left in this image. It just gets drastically worse.
That's weird.
So yeah, you'll see in a minute.
So that whole damn island should start looking like it gives curve, but it doesn't. Yeah,
well, this is what I was trying to say at the beginning of the show. When you see this line in a minute go up on the left, it'll be going from right to left. It'll be curving upwards on the left-hand side as we get further and further out in terms of the distance we're seeing. Well, as that happens, if we're to believe that it's being brought back by refraction, we have to assume that that refraction is graded such that it can bring it back in perfect proportion to compensate for the ever-increasing curvature that we are experiencing as we look at it. The reality is, we're not looking at anything Mirage. There's no distortion. There's absolutely zero chance that non-standard refraction is going to bring it back into view in perfect clarity on a gradient, on a curve. It's just nonsense.
Plus,
Joined by Mr. Flat Curve. How you doing, Mr. Flat Curve?
Good, thanks. How are you?
Very well. Good to have you here.
Cheers.
How far away is that lighthouse? How far away is the lighthouse? Don't tell me I'm getting sniped. Seriously.
I hope not. I'm just fiddling with things.
Right. I'm back.
Hey, sleeping. How far away is that lighthouse? Do you know?
31.5, I think it was.
Miles?
31.5 miles, yeah.
Just before we do anything
So
else, though,
what's-
can you just show this image? I'm sorry to cut you off, Make for just so we carry on the point. So can you just slowly scroll from right to left, Anthony, on this image?
Yeah,
sorry,
I mean,
the other way.
I'll zoom out a little bit so that we can make it a bit quicker. Well, basically, this is the lowest point of the island, where basically this is the point where curvature should be cutting off, and it's the lowest point to us. And the way how we got these figures is he planted blocks on Google Earth that were the same height as the hidden, and he joined them all together and then removed all the blocks. So they're as accurate can be, and he gave it quite a thick line to allow for a little bit of refraction variation based on the atmospherics. But as you go further left, it should gradually get more and more, but then it should start increasing.
Why don't you Photoshop this to bring out the brightness and the contrast a bit more?
I think Ranty has done that, but when you do that, the problem with doing that is that, yes, it makes the contrast brighter and whatever, but it also makes other parts go missing, and it swings and roundabouts. You can do that. But I mean, you can see that the land down here is clearly land, and it's not.
This is the contentious bit. So this is what, when we get beyond, in a moment, when we get beyond the bit that's almost joining with the line. So everything below the line should be hidden by the curve of the Earth. Everything above the line is potentially visible.
And I think from memory, this is where Douglas is. This is where it drops down, and I think Douglas is in this corner here. Originally, I said
look straight, but
no, that's because it's an exponential curve going away. It gradually gets quicker and quicker and starts becoming more severe.
Can I just explain it to Mate 4, because again, so I can make it clear for the audience. It's because of the orientation, because we're just looking at something that looks like we're looking across from left to right at this island. We're not. We're looking further down the coast. So this bit that we're looking at is 50 miles. The Lighthouse was 30 or something. I didn't know the exact figure when I was asked earlier. But basically, we're looking further and further away as we go from right to left. Therefore, the curve increases exponentially. Therefore, at the end of the image, it should be blocked by exponentially more than the beginning. And this is where we have this land. Now, the giveaway for me is where you said Douglas ends. We have this refractive band underneath the land start. I don't know if you can zoom in just to show what I'm talking about, Anthony. So there's like this thin line.
Mirror thing.
Yeah, we got the sky bit appearing here, but what we also notice, just to flick back out again, Douglas is down here at the just down here somewhere, but back up here we have that same effect. So for some reason on the extreme right of the shot, and we're towards the left of the shot, we have the same atmospheric condition.
That would be the more water around the edges of the island reflecting off more or something.
Maybe, but if that's the case, if that's the case, that means that what's beyond that refractive effect on the island in the foreground, the Isle of Man, beyond that is what we have left, the extra land, which can only be one thing: island.
Yeah, because there's far too much of it for it to be anything else.
Correct.
But look, yeah, we have that little bit of land there. And then if I zoom back out again.
And if it was refraction, I mean, how would it work? Does it bend in a curve? I mean, how does this refraction even work? If it bends in a curve, do you get like a ring of light that can be bent into a circle or something? I mean, and also if it's bending it down at a point to the Earth, wouldn't there be a zone in which you couldn't see it? Then you'd get into the refractive zone, see it, and then go further forward and not see it again. I mean, how does it even work?
Well, sorry, Anthony. I just want to feel that. Sorry, just want to have a go at this. So, in the line that Anthony's about to point out with his mouse, that's where I would contest that what you've just described is happening. Exactly that. We're losing the last 20-metre high piece of land on the end of the Isle of Man to that refraction. That's what we're losing. And then the reason we have it all the way to the left-hand side of the image is because that's where we're seeing the greatest distance. Damn, we're all going to get smoked.
Well, I mean, I'd hate to just keep harking on what Samuel Robotham said, but, you know, his mechanic seems to work. I mean, we know that light in general propagates in straight rays. So if the rays are going up, down, they're eventually going to converge at a point, which would be the horizon line that we think we're seeing. So light would work in this fashion, and you'd have a vanishing point where the bottom of objects would tend to drop off first. I mean, if you were, you know, hypothetically floating in the air, you would have a full 360 panoramic vision up and down. But when you're on the ground, half of that field is cut off. And so therefore, stuff that would, disappear uniformly in the distance if you were up in the air, you'd see the top and the bottom of the object disappear up to a point where the thing would just, disappear off into the distance evenly. But when you're on the ground, half of your field is cut off. So the bottom would naturally disappear first. And so that's why we don't see the object of the bottom of objects when we're on the ground. Now, if we're in the air and we could get a full view of anything that we see, then it would disappear uniformly. But the ground changes that dynamic.
Yeah, this was discussed on yesterday's show, and it was described as specifically atmospheric lensing. So after the show finished, I did a cursory Google search and tried to find what came up with that exact phrase. And almost everything, I'm going to say everything, I can't say everything because I haven't looked through the entirety of Google, but everything I came across was specifically in relation to curvature.
New guest.
No, it's Mr. Flat Curve. He's just got network problems.
Kicked out, sorry.
So,
right.
Make 4, can you see how the line of sight is looking right the way across the length of the country rather than left to right? It's looking down it.
Oh yeah, I understand what you're saying. So yeah. I'm with you.
So we should see that curve, that curvature, if it's going to be there, and we should see it. We should see evidence of it.
Well, it would. Yeah, it wouldn't. You wouldn't really see it, but the island should definitely disappear quicker than what it does.
Well, what I'm going to do is I'm going to put it out there because I know Paul's in there. He's watching. He's not he's not commenting, but he is watching because he was writing.
Disappear below that horizon much quicker, and at the start, like.
Well, no, if you imagine is what we should see, Make 4, is everything above the red line. That should be the image we get if the Earth is curved.
So what I'm going to suggest is I'm going to make the assertion now that at this date, at this time of this hangout, if you're watching this hangout live or if you're watching it in retrospect, this is the most up-to-date position that we're at. This red line is meant to be the curvature of the Earth because there was obviously a real problem because Jeremy didn't get it, clearly didn't get it. What's his face? Lewis didn't get it. They didn't understand that even if, let's just say for the argument's sake, that the lighthouse was incorrect, the little bit at the bottom, even if that was incorrect, this is how much curvature it should be hidden by. So, and it was, I don't know whether it was an intention. I'm going to give Jeremy the benefit of the doubt because Jeremy, I quite like Jeremy, but I think he's one of the more genuine people. But he didn't understand or he didn't seem to grasp that all of this should be missing. And if you're arguing about the flat tire at the very bottom of the thing, but ignoring the fact that the wheel should be missing off the car, what does that say about the level of the opposition? I mean, come on, the point is all of it should be missing and some. So it's like, come on, there are explanations for what we see for this bottom bit. And I can explain the bottom bits completely based on the evidence that we've got. But I don't really want to labour that point too much because it's Ranty's little baby and he's done all the work on it. But also it's irrelevant to the bigger picture. The bigger picture is Jeremy brought up the lighthouse, fair play. But what about all this stuff? I mean, this was the first part of it. I mean, he's gone with the very, 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 very first point, which is like so premature, like not premature, but it's so early into the evidence that, there are better things that we can discuss. There it is.
What's the highest peak of that mountain? How tall?
2,200.
That island.
2,200 feet, I think. I think this is Snaefell Pike or Snaefell Tower. I'll bring it up on screen so you can see it. Snaefell is, I think it's this one. Let's see whether it's going to give it. Oh, it's because I've got line tool on. Let's get rid of line tool. Turn ruler off. No, Snaefell.
I don't know.
This is Snaefell. This is where the mast is. And if I just drop the cursor here, for example, 2,600 feet. No, hang on. 2,000 feet. I was looking at the wrong one. I was looking at high altitude. So it looks like it's bang on to 2,000 feet, give or take a few feet. So back to the image, that is 2,000 feet up there. It's just in the clouds. There's a thin layer of clouds blocking what we see. So 2,000 feet, and then whatever down at the bottom. I mean, the lighthouse that we were talking about yesterday was only 70 feet, I think it was, off the top of my head, on top of a platform of 150 feet or something like that.
Get someone to go to that lighthouse with a laser.
Yeah, we could do that, but the problem is, if it's very rural and it's privately owned now by no less than Jeremy Clarkson, the BBC TV presenter.
I was so tempted
Oh,
to
he's
call
a
the papers this morning and say that Jeremy Clarkson's Lighthouse shouldn't be visible because it should be blocked by the curve of the Earth. We'll be covering this subject on the Flat Earth debate.
I have tweeted him to see if I can get a response out of him, because once I found out it was owned by somebody like somebody professional or whatever, I figured that it would be a good idea to try.
How you doing, Paul?
Good. Sorry, I've been on the phone to my mum. That's much more important than this. So
I agree.
but I'm here now.
Oh, good. I'm glad you're here, Paul. I hope your mum's okay. Let's talk non-standard refraction, Paul. What can we talk about that?
Yeah, go for it. Yeah, can I share a few things first?
Sure. Floor's yours.
Okay, thanks. Let me just get the right stuff up that I need. Okay, the first thing I want to share is this. Just a little light-hearted humour to start it off, but just to set the scene a little bit here. Okay, so what we've got here, that's the refraction equation for the refraction coefficient. That's how we calculate the refraction coefficient. But I'd like to ask Nathan, where do I plug in the phrase glorious day into that equation? Where do I put the absolutely glorious description into that calculation?
Is it
You
calculating
obviously cannot
for?
put things in there.
Is it calculating?
So should we calculate?
Is it calculating for refraction?
Should we calculate the refraction coefficient by saying, oh, 530-ish multiplied by a bit of high pressure divided by a bit of cold squared?
I'm just asking a question, Paul. Does the calculation
multiplied by 0.0? Okay.
Does the calculation account for things
we don't
obscuring our view or making our view clearer?
Okay.
Is it a calculation for things making things clearer or things?
So we need to put some. Yeah. So we need to put some real numbers.
It is. It's a calculation for making things clearer.
Numbers into this,
is it a calculation for making things clearer? It says refraction at the top, Paul. It says refraction.
Yeah. Okay. Yeah,
well,
but
is refraction the same as making things? Hold on, I'm asking a question, Paul. Is refraction the same as making things clearer?
No, refraction causes bending of light.
So why are you asking me about where we? Oh, sorry, Paul. Why are you asking me where we put the clarity in then? If it's about refraction, I don't really understand the point of your question. It seems like a pointless question. In fact,
it's not, because we don't know what the refraction is unless we put some.
You're talking about refraction again there, Paul. Sorry, Paul. Your original question to me, Paul, I'll just paraphrase what you asked me. You asked me where we plug in the clarity of the day. You asked me where we plug in the clarity, Paul. Paul, you're back talking about refraction, Paul. You seem to be talking about refraction again. Are we talking about clarity or refraction?
You can't make. Well, both.
No. We seem to be talking about refraction here, Paul, not clarity. We seem to be talking about refraction.
Well, would you like me to calculate the refraction?
No, well, you asked me specifically about the clarity, Paul. Paul, did you forget what you asked me?
I know.
Have you lost your smug point already? You asked me about the clarity. So, no, I don't really want to talk about the refraction. I want to talk about the clarity.
I want to talk about
refraction.
refraction.
I want to talk about the refraction, seeing as that's
well, you better talk to Anthony then, because he's more interested in the refraction. I'm interested in how clear it was.
Yes, I want to talk about refraction, Paul. Let's aim Nathan's questions at me. Why are you applying maths that's not the maths for your model?
It is.
No, it isn't.
This is the refraction coefficient. This is one way of calculating refraction.
Right, but the way that your maths...
Obviously, there are different ways.
The way that your maths and your model does not do maths that way, does it?
What?
Your model tells us... No, it doesn't. Can we use the maths of your model, please?
The way it's done. This is the maths of the model.
No, Paul. Let's use the maths that's cited on the website that everybody goes to. Not your maths.
Okay, let's do that. Okay, so let's just go there then, shall we? Okay.
You know how?
All right.
I said we could just like wait for the better P900 and just chill out and have some beers. Kind of really meant that.
Yeah. Well.
Okay. Just wait. I'll get there. Okay. Here we go. Not quite sure where you're getting your information from.
the same place that all the ballers and the flat earthers go because it's supposed to be the most accurate and credible site because it allows for standard refraction. So let's go to the Metabunk
What
site.
No, this is not the Metabunk site.
That's your maths, Paul.
Okay.
That's what we should be applying.
What site do you think this is, Anthony?
We should be applying the Metabunk maths. That's where we go for the...
That's bloody Wikipedia, mate.
Atmospheric refraction.
No, Paul, that's not the maths that we apply.
I didn't get this. I didn't get this from the Metabunk site, Anthony.
But that's my point. You should be doing because that's what the maths is. So let's go to the Metabunk site because that's the maths. Yes,
it's the same maths.
I just want to remind Paul. I don't want to have to edit this into it. Sorry, Paul. Can I just remind you of something? You took us to that site. You were very keen to say, "Have you read this? It says click here." I don't mind editing that.
Well, I can go to that site.
You were the one who took us to it originally,
math.
Paul. You don't seem to be. Okay. You don't seem to be acknowledging my point here.
Shall we go to...
Paul, you don't seem to be acknowledging my point. You took us there very indignantly, pointing out that you haven't clicked here. Well, he had clicked here, and he did know what the maths was. You took us there. Now you don't want to take us there again. Why?
He's moving the goalpost.
Well, I'm quite happy to take you there again. All right,
the Hobbit.
I'm happy to take you there again.
Let's do that then.
Is the same.
Let's do that then.
Huh?
Let's do that then. You took us there originally. Now let's take us there again and have a look at that maths that shows we can't bring it back with refraction.
There's something in Labyrinth that sounds like that. The little...
You need to bear with me. I've got to find where it is in here. There's so much in here. I've got to find out where it actually is.
It's okay, Paul. It's 7/6R. That's the maths.
No.
Yes, it is, Paul.
No, Anthony. No.
That's the maths,
You're
Paul.
making the same mistake again. You're making the same mistake you made the other day. Where do you think that 7/6R comes from? I am astounded that you cannot understand that. I'm going back to here and show you where that comes from.
Does it not say it on screen right now, Paul? You've just come back off the screen. You've just gone back off the screen where it literally says take a value of 7/6 with your man that you referred to saying it. Did you see it? There we go. There we go. Looking more for deviations.
There it is.
Oh, you've scrolled past it, Paul.
There it is. There it is. Here it is.
That is a different set of maths.
Is.
It's a different set of maths.
That's where the 7/6R comes from.
Right, but what you should be applying is the 7/6R because that's what's the cited.
7/6R. Oh my God,
Paul, that maths I agree with, but it's not cited on the refraction calculator, and we're talking about refraction. Go back to 7/6R. That's the calculation.
This is the page. This is the page of the refraction calculator.
If it's the same, Paul, what's your problem?
I am on the Metabunk site.
If it's the same,
I am on the Metabunk site here.
Good question. I'll just ask him. Is it 7/6R that this calculation comes out to? Hold on, Paul. Paul, does this calculation come out to 7/6 or not?
It does if you use standard atmospheric conditions. Yes.
So where's the calculation for non-standard then?
And I can show that.
Yeah, but hang on.
That doesn't refer to the refraction calculator, does it? You've just said this does refer to refraction, Paul. Now you're saying I can take you somewhere else.
This is on the Metabunk site.
Yes, and it's 7/6. And it's 7/6. You've just admitted this. It's 7/6 that this works out to, correct?
What is wrong with you?
Is it 7/6 or not? We've already had a yes from you. We've already had a yes, Paul. We can just edit this together while you go, oh my God, yes, it is 7/6.
What is wrong with you?
Nothing's wrong with us. We're applying the maths for refraction. Do you want to go back to clarity, Paul? Should we go back to clarity? Are we getting frustrated with refraction already?
No, we're talking about
getting frustrated with the refraction problem already, are we, Paul? Should we go back to clarity? This is 7/6, correct, Paul? Now, are we going to stick with this or go somewhere else? You've just said this is Metabunk, this is refraction, and it is 7/6.
This is the same formula I had on the other page. You made me go to a different place to get the same formula.
And will it come out at 7/6 or not?
Listen.
Oh my God.
I'd like
Will
to
it?
start
Why
with
don't you want to
standard.
answer? Will it come out to 7.6? Yes or no?
Yes, it will if you let me show you.
No. We just need a yes or no. We don't need to be shown anything. We've got it on screen. Yes, it comes out to
Yes,
7.6.
it will.
So
It's
7.6 is what we'll use.
condition. It will come out to 7.6R
Excellent.
if you use standard atmospheric conditions.
Like we've got on this
If
site that
you
we've just
do
been
not
taken to.
use standard
Yeah,
atmospheric
that's what we're going to
conditions,
use
it
because that's
will
the site
not
we're
come
referring
out
to, Paul.
7.6R.
Are you going to take us somewhere else now to take us so we're not using 7.6? Is that what you're about to do, crafty man?
I beg your pardon?
Are you going to take us
don't
somewhere
make
now
sense.
that doesn't
That
use
it's gotta be
7.6?
standard
Yes
refraction all the
or
time?
no, Paul? It's a simple enough question. Are you now going to take us with some trickery somewhere that doesn't use 7.6? Yes or no?
I am going to show you that under varying atmospheric conditions.
Are you
it
going
can
to
be
take us
different
somewhere
than
that changes this
7.6R.
maths that you've just taken us to refer specifically to refraction
No,
at
I'm not gonna take
7.6?
you anywhere else.
Is it going to change to something
Will
other
you
than
let me do
7.6?
a calculation?
Yes
Why are you so
or
afraid
no?
of letting me do a calculation,
You don't seem to be
Nathan?
You don't seem to be able to answer a simple
Why
question.
are you so afraid of letting me do a calculation to show you?
So does it change from 7.6 when you do this calculation?
It changes from 7.6 when you use non-standard conditions.
Right,
And
so
I
we
would
got
like to
there in
show-
the end. So we're going to change this calculation on this specific site that refers specifically to atmospheric refraction, and we're going to change it, correct?
Oh, that's because it does change under non-standard conditions.
What
Which
non-standard
part don't
conditions,
you
Paul?
understand,
What
Nathan?
non-standard
That under
conditions? A
non-standard
clear day, like you
conditions,
asked me when you came in?
changes.
A really clear day?
Non-standard conditions.
Like a really clear day?
Because standard condition. Because standard
You think
conditions
it's a mirage?
refer to
Paul, you're deluded.
all distances.
Paul, you're delusional.
That's it. How
You
do
think it's a
know they're
mirage, Paul?
non-standard
You're
conditions?
deluded. You're a fool. You think it's a mirage.
We're hardly giving him a chance.
All right,
really,
prove
to
it.
He's
be
already
honest.
done it. I've seen it
my
once.
mate.
We've had an
You're not giving
entire
a chance.
hangout
Why
on
are you
it.
so afraid? of
I've
letting
seen
me
it.
do the
You've
calculation?
done it. We've
No,
seen
you
it
have
on
not.
another hangout, Paul. Now I need you to explain
When?
why we've lost the bottom section.
You're asking me to explain it, and then when I want to explain it, you won't let me.
Right,
We've
hang
got
on, hang on.
refraction
Let me-
calculations. You just want to change them.
I want to explain it, and you won't let me because
No, you
don't
want to change them.
understand
We're here
it.
on the Metabunk site. We've established that it's 7.6. Now you're saying I can explain the calculation differently and make it different. I can make it not 7.6 because that
That's
doesn't
right.
work on the globe.
That's
Well,
right.
poor you. We've heard it all before. We had an entire hangout on it. I'm bored of it.
No,
You're
we
gish galloping around the fact that we can see it when we shouldn't, and you're trying to make it work with maths.
Hopping
Your
around
maths
the
is
fact
never
that
going to
you
work.
don't want me to
Well,
do
I'm going to ask you a
calculations
question, Paul, then I
because
will
it
shut up.
shows
Paul,
that
I'll ask you
can
one question if you'll give me the
explain
chance.
what we
I'll ask
see.
you one question, Paul, and then I'll shut up. We have a very severe problem. The far left-hand side of the island should be behind considerably more curve than the left-hand side of the island. Are you proposing
I've
to
heard
me?
this all
I'm not going to
again.
get to the end of my
We've heard
question,
this
Paul,
a
before you talk
million
over me.
times, Nathan.
Are you going to talk over me immediately? Are you proposing
Well,
that
you
this
talk
maths
over me.
calculation can account for the fact that we have, or should have, exponentially more of the island obscured?
No,
Does this
not
maths...
exponentially. You're inventing that.
No,
Where
we've
does
just seen
say
it
that it's
depicted.
exponential?
Yeah, because we're seeing further away. Would you concede that as we see further things further away, they go further behind the curve, or not, Paul?
Yes.
Would you concede that the left-hand side of the island is further away than the right-hand side, Paul?
The fuck?
Yes.
Right, so you would concede, therefore, that the left-hand side of the island should be further behind the curve than the right-hand side of the island, would you not, Paul?
That is correct.
Right, so
You haven't
how
told me
will this
anything that I
maths
don't
account
understand.
for the ever-increasing amount of curvature that we should see towards the left-hand side of the island? Are you going to
Right.
calculate this refraction mirage continually along this curve? Or will one maths equation do the whole island, Paul?
Are you going to, now that you've asked the question, let me answer it? Okay. This equation here is the equation that, am I still on?
You are.
You're still rocking, bro.
Oh, okay, just everyone went quiet. I'm not used to that. This equation here is the refraction coefficient calculator. It calculates the refraction coefficient for any pressure, temperature, and temperature gradient. That's the rate at which the temperature changes as you gain elevation. Okay? For standard atmosphere, the pressure is 1,030 millibars. The standard temperature for a standard atmosphere is 20 degrees Celsius, but the equation requires you to use the temperature in degrees Kelvin, which would be 293 degrees Kelvin. Okay? The standard rate of change of the atmosphere as we normally go higher in altitude decreases. It decreases in temperature. So this temperature gradient is negative. It's been measured and it decreases at a rate of 0.0065 degrees Celsius per meter. You can go look that up if you like. That is the measured rate of change of the temperature. So I'm going to put those calculations into this scientific calculator here and calculate what
for which part of the island, Paul? Just before we go any further, which part of the island are we calculating for? Which part of the island?
Okay, so
which part? Sorry, Paul. Just need to get clarity. There are.
Are you going to let me?
I just need to get clarity before you do the calculation, because there's more than one part of the island, and it's ever increasing in the amount of curvature it should be obscured by.
Yeah, and
so I'm trying to get
just
clarity on which part of the island you're calculating it for.
I'm not calculating on any part of the island at the moment. I'm doing the standard calculation to show how it works out to be 7/6R. Is that okay, Nathan?
Yeah, you go ahead, Paul.
I'm showing you how this gets the value of 7/6R. Is that okay? All right. I'm showing you where this value of 7/6R comes from. It's not just plucked out of thin air. This equation actually gives you the value of 7/6R. No, you listen.
No, I just want to say one thing.
I want to do this calculation to show you.
Guys.
I know, but all I'm saying is at the end of it, Paul, we're going to be going back to 7/6R.
We'll do it at the end of it then, Riley. I mean, I'm just going to say something quickly. Why the hell is there so many flat earthers in here, and the moderator feels the need to have to talk over and argue for you? Doesn't say very much about the flat earthers on this panel, does it?
Well, Nathan can mute all. I mean,
okay, I need you to verify that I'm doing the right thing here. Okay, so I'm typed in 503. We're now going to multiply that by standard atmospheric pressure, which is 1030 millibars. We're now going to divide that by 293 degrees Kelvin. And we're going to divide it by 293 degrees Kelvin again, because it's temperature squared. Now we're going to multiply it, and I have to use brackets here. We're going to multiply it by 0.0343. Okay, and minus the temperature differential, the temperature gradient, which was 0.0065 degrees Celsius per meter. And this value that we get is the refraction coefficient, 0.16777. I'm going to write that number down, 0.16777. Now, what fraction do you think that is? Because I am now going to do 1 divided by 6. And what do we get? We get 0.1666. That is so close. That is where the extra 1/6 comes from. And when you add the 1/6 to 1, you get 7 on 6. That is where the 7 on 6 comes from for the standard model. Are you happy with that?
I'm overwhelmed. Can we now go back to the 7/6R?
Right. Now what we're going to do is we're going to put some values in for non-standard.
Wait, we'll come to non-standard.
I am going to do the calculation now. You're not going to cut me off here.
There's no point
I am going to show you now
I'm not interested in the
happens at
calculations. I'm
non-standard.
interested in the physics.
No, you're not
Paul.
interested because
I'm
it
interested in the
shows you
physics.
what the explanation is.
Yeah, that's true, Paul. That's why
I'm
they're
interested
cutting you
in the
off. They don't
physics.
want you to
Yes,
finish.
I am going to do this calculation. This is
Right,
the
but you're
physics.
wasting time.
You
I'd
let me
rather talk
calculate
seen
it
all
for
this.
standard refraction,
Seen it once.
and now you're not
We've
going to
already
let me
seen it.
calculate it for non-standard. because
Already
it
seen it.
talk
If
about
anybody wants to
explain-
see it in the audience, if this
Maths,
turns into
Paul.
another debate, you can see it on Flat Earth Debates number 81. Paul does this at length, at nausea. It's incredibly tedious.
I want to talk about the physics,
not.
Paul.
Well, I'm not surprised it's incredibly tedious for you because you're sitting there having to try and argue something you don't understand. Of
No,
course it's
Alex
tedious
is
for you.
angry about
Not
there being
quite in
no
the
curve
maths.
as well.
Now,
Bless him.
Let's
Oh.
do it now.
You're going to unsubscribe, Alex. You're going to unsubscribe.
No, I'd never unsubscribe from this, Nathan. Never. Never.
Good
you
lad.
sit here and you talk over me while I'm trying
Yeah,
to
it's really
explain
frustrating,
something,
isn't it, Paul?
and then you say you don't want to hear the explanation.
Really
Don't want to hear
frustrating.
the maths.
You
Don't wanna hear
ask
about the
me to
physics.
explain something,
And then tell us,
you
Paul.
don't
Sorry
want
to
to hear the
interrupt, Paul.
explanation.
Tell
How
us, tell us.
disingenuous is that?
Tell us where it is
Paul,
then,
what if
Paul.
the
Tell us
physics
where that
contradicts
curvature
you?
is.
Right.
Tell us why it's missing.
Go through the calculation. The calculation is 503. Right? Now, you said it was a nice day, so we're going to use the same atmospheric pressure. I'll give you that. The same atmospheric pressure that you used before. So that's not going to change.
But isn't
I'll
it based
give
on
you
an
that
average?
one.
I thought it was
So
based on an
times,
average. Isn't it
just
based on an
listen.
average, Paul? Isn't it based on an average?
1030.
Hold on. Are we not going to adjust that part of the
Now we're gonna
calculation, Paul?
divide
It's,
it
I thought
by-
it was based on an average.
We're going to divide
Nice
now
day. This is the
by
point you came in
the
and started to
actual
quiz me
temperature.
with your little
Are
thumbnails
you just
up,
going to
Paul.
sit there and talk
Yeah.
over me
Yeah,
so that I
'cause
can't
you're really triggered and
explain
it's
it,
funny.
Nathan? You
The
get
audience
very
loves it.
discourteous.
The audience loves it, Paul. You don't get it, do you? You're really triggered. You're really angry. And every time you react the way you do and shout, the audience gets more appreciation from the audience. They like it. So yeah, I'll keep doing it because you're annoyed.
Just let
We've
me do
heard
the
all this,
calculation. I'd
and I
like
don't
to
care
do
about
it
talking
calm
over you
down.
because we've heard it all
You're
once.
the most triggered
I
guy
am
I've
doing the
had.
calculation.
Okay.
You're a moderator.
Okay,
A moderator
divide. I'm
who
going to
comes
ignore
to
you
the
now, and I'm
flat
going to do the
argues with
calculation
only
anyway.
caller.
Right?
Yeah, let's hear it again.
Divided by
Heard it on Flat Earth Debates number
temperature
81 if you want to check it out for yourselves
Hey,
without me
temperature.
interrupting because I'm a terrible
Oh,
moderator.
Nathan, if
How you
it's on
doing?
Flat Earth Debates and you remember it, you
You're
can explain this.
incredibly
yeah?
rude, Nathan.
Yeah, I know. Very rude.
No,
Like you were to
get
me
Na-
when I
get
was trying to
Nathan
ask you where the
to explain
curve was and you kept interrupting me.
No, Nathan.
Well,
you
how about
explain what
Nathan
Paul's
explain
talking
it then?
about.
Yes.
Yeah. you
I'll explain it, no problem.
know it
What am
so
I
well.
talking about?
Okay, yeah, no
What am I
problem. I've got
going
the
to
floor
do?
over, Paul. I've got the floor. The Earth's
Yeah,
flat.
explain
We
what
see
Nathan
it
explained
because we've got a zoom camera and it was a clear day.
No,
That's not mathematics.
the equation. We
No,
want
no,
to know
it's
that.
simple.
Do you know that?
Simple
You're gonna
observation,
have to
actually,
explain
Paul. Don't need any maths to explain seeing things. It's simple.
Right.
We look, we see them.
I know the
Simple.
equation.
Don't need any equations. We're not looking at any photos right now.
Oh, so
We're
you
just
don't know
looking
the
at your
equation,
numbers
Nathan,
being plugged
even
into
though you
Google
said you
Calculator
went through ad
because your phone's
nauseam,
broken.
But you don't know it. You don't understand it. You didn't understand
Did
it
you not
when
hear?
did you?
Sorry,
So
maybe Alex is deaf. He's triggered also. If you would like
no,
to
no,
hear
I'm
this
triggered.
again, feel free to watch Flat Earth Debate number 81, where Paul goes through it in detail.
Don't get
We
triggered,
all
Nathan.
listened.
Don't do
So
your
you
girly
did
not
not
do
then.
this
No need to do your
calculation.
girly voice, Nathan.
And he
Yeah.
didn't do this calculation.
New
so
dish
you weren't
gallop.
paying
I did
attention.
not do this calculation.
This calculation isn't going to
I
account for the
didn't do
fact
the
that it gets
calculation.
exponentially more behind
Okay.
the curve,
Throw
Paul.
his
Now,
sleeve out the
We've already
back.
addressed this. You're not addressing it, you're ignoring it and
I've
keep
already
doing the
looked
same
up
calculation
what
over and over
temperature
again.
it's in
To try and
today.
explain
I'm
with
just
your
gonna keep
maths
talking with
how
you
it's
all
not
day, right?
non-standard refraction, how
What
we can ignore the
temperature it's
calculations
in
we're given
today
by the
is
authorities,
10
the
degrees
ones that
Celsius.
Paul has referred
The air
to,
temperature
the
on
ones
St.
that Paul has
Peter's today
taken us
could
to
not
in
have been more
reference
than
in his
13 degrees
indignant
Celsius
tone,
because
saying
the
click
maximum
here,
for October
click have
was
you
13
clicked
degrees
here to see
Celsius.
the reference for
That leaves a
refraction.
temperature
We're supposed to
above
ignore
the
all that now
water.
because he's got new maths that he wants to show us. He wants to gish gallop around what he's
And you're not letting
referenced
me
and
show it.
taken us
Oh,
to.
maths is gish
He wants to gish
gallop
gallop around
Why
that
you
because
just
we
keep-
can see
why
things
you
we
keep
shouldn't be able
pretending
to
you
see.
understand it, Nathan?
And they're exponentially further beyond the refractive index we're given to use to calculate these things. That globers usually co-opt and say, look, you're seeing the curvature, that's why the bottom of the building's missing. And look, we've got a lovely calculation for it. And it's all laughter and we're all idiots. This time, Paul,
Yeah.
you're delusional. We see the island. It should be getting exponentially further behind the curve.
I'm
You
not
can't
the
account for this
delusional
unless you
one
do
here,
an
Nathan.
enormous,
You're the delusional
enormous
one
maths
because you're
calculation
afraid-
to
you're
explain
afraid
how a
he's
mirage,
afraid to see
a
the
mirage has
Nathan.
perfectly become
Afraid
balanced
to see
as it goes
calculation.
over the curvature
The
with
calculation
refraction
might show
that's
that
non-standard.
you're wrong, Nathan.
It's the biggest load of
The
gish gallop I've
calculation
ever
might
heard
show
in my
that we
entire
have an
life.
explanation
All the
for this
Glovers do is
curvature,
join and
Nathan.
tell me how I should be
The
shutting up because I'm a
calculation might show
moderator.
that you're
And
full
I'm
of
trying to
crap,
moderate
Nathan.
your complete fantasy and nonsense. We see it because it's
Nathan
there,
said your
Paul.
picture was
We
great.
see
It was
it
so
because it's
clever.
not a
Now,
mirage.
are
We
you
see
going
it
to let
because
me
there's no
explain?
curve in the way. We see it because it's there.
This is the other
It's not a
side
mirage.
putting fingers in their ears and going, nah, 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 nah,
I've
nah,
heard all
nah,
this.
nah,
We're not
nah,
putting our
nah.
fingers in the ears. I'll say it a third time for the benefit of the audience. If you want to hear this, go to
And I'll
Flat
say
Earth
it
Debate
a fourth,
81.
fifth,
Be the
sixth,
moderator.
17th power of 99th time.
Bored of it, Paul. Bored of
You
it.
don't want to hear the explanation because you know that it explains what we see.
What we see is what we see. You're saying we don't see it. You're saying it's behind the curve
I
and
have
it's being
the
miraged back around the
You
curve
don't
with
want to
maths.
hear it.
We see it. We
I
don't not
have
see
the
it, Paul. We do
explanation
see it.
and
You're
you
trying to
don't
explain
want to
how
hear it.
it's actually not
Nathan
there.
Hurst.
It's actually behind the
What are
curve.
you afraid
We don't
of,
really
Nathan?
see it. It's
What are
being
you
bent
afraid
by
of?
refraction.
Are you
You're
afraid
trying
of
to
a little
explain
bitty, bitty
how
bit of
it's
maths,
an
Nathan?
imaginary effect.
He's afraid of his midlife crisis coming to
Hey,
an end
wait.
and having to go back to the real world.
Yeah.
Are we
A
still
little
talking
itty
about-
bitty bit of maths might prove that it's wrong.
What might prove that it's actually behind the curve and being refracted around. We're not really seeing it. It's a mirage.
And that's what you're afraid of, isn't it?
Not afraid. I can see it,
You're
Paul. I'm not afraid of
that
anything.
what
I've seen the
I'm going to
pictures.
tell you is quite
You're going to try and
reasonable.
convince me that it's being miraged
And
around
you're
the
afraid
curve
that
in
quite
perfect
reasonable
symmetry
things
and
that
looks
I'm now going to
beautiful,
explain
even though it's
show
ever
that
increasingly
your
getting more
explanation
behind
is
the
a load of
curve.
rubbish.
You're not going to do it with
Wait,
maths,
wait. Are
Paul.
we still
You're not going to
talking about
convince
the
me that
picture-
what I'm
this
seeing
picture
I can't
of
see. It's not a
Island Man?
mirage.
So first you could see island on the right-hand side.
We see
and
all
then
of
you
it.
could see island on the left-hand side.
See all of it.
And then we couldn't see island, but there's missing curvature.
See all of it.
What are you going to shift the goalpost to next?
I can't believe we're still talking about these
They
pictures.
still
Like,
It's because we see all of it.
I
And
know.
Paul wants to convince the audience with maths that
those
we don't
pictures
really
were
see it. It's just a
bold, and
mirage.
they're still trying to push
And
it.
where's Randy
Non-standard
Okay.
refraction bending the hidden
Are
item
you
back
going
around
to
the curve.
actually
Complete
be
horseshit.
polite enough
Total
to
nonsense.
let me explain
Heard
the
3 days of it.
calculation?
It's just boring now. Won't accept the fact that we can see it.
That's
Wants us
because
to believe it's
dragged
behind the
it out,
curve.
Nathan. I could
Wants
have done
me to
this
believe that I'm not
1
really
minute,
seeing
but
it.
You dragged it out by all your interruptions.
We see
could
the
have had
island,
this
Paul.
done
It's not
long
behind the
ago,
curve.
Nathan,
It's not
but
being
you don't
dragged
wanna
back
hear it,
by
do you?
refraction. We see it.
We'd have been
Simple.
done 10 minutes ago, Paul.
I can't believe we're still talking about
Yeah,
this.
I know.
Oh, it's boring.
Like, this is crazy. Like, we already debunked that he wasn't even looking at
You haven't
Douglas.
debunked anything.
Yeah.
And the fact that
You haven't debunked
They
anything. You're
took
trying to
24
explain
hours
it
to give us
away
the
with
claim.
maths. Trying. Failing.
We have. You're not listening to it, Nathan.
Yeah, you're trying to explain that it's a mirage, non-standard refraction. I
How
understand what you're
dare
trying to
I
do, Paul.
use
It's not a
maths to
mirage. We
explain
see it.
anything, Nathan. Ooh.
You're trying to use math.
I'm trying to use maths. Ooh.
Does my
Get that
makeup-
maths away from me.
Okay.
who brought this up?
Does my
Maths
makeup
doesn't
look
explain
okay?
anything, does it? No. I'd rather use "It's a glorious day, therefore we should be able to see Ireland."
Yeah, that makes no sense.
What a load of
I mean, the
Yeah.
picture
It's
was
clear day
Yeah,
so we
you're
can
right.
see more.
See
No,
what
no, no.
Douglas
No, no, no,
was.
no, no. You're not seeing any of it. Really, it's all hidden behind the curve. We've just got this amazing effect where the furthest part of the island happens to be bending around the curve so much more than the nearest
And
part of
it's
the
actually
island
not that
because
amazing, Nathan.
that's how
It's
refraction
actually
works.
not that amazing.
Watch, look, my maths
Anthony
will show
showed
you
it
how
to
the
me.
furthest part of the
Really
island can
isn't
bend
that
around more.
amazing.
Paul, remember Anthony
It
showed us
only
that there was the
takes
line
a
of-
difference in temperature of 1 degree Celsius above the water for a distance of 20 meters to completely explain this.
And what about the near
Oh, but
side of the
that would
island,
be
Paul? That's
impossible.
at the far side of the
We
island.
can't have a temperature gradient of 1 degree Celsius in 20 meters.
So we've got a
That's
varying
impossible.
temperature gradient, Paul. So that temperature gradient varies along the length of the island. Does it to perfectly proportion that island and bring it back into perfect proportion around
Yes,
the curve?
it
Is that what it
does.
does? That temperature gradient, does that vary along the length of the island, Paul?
But the distance
trying to say
varies.
water?
You know, and hold on,
You
let's
have
get an
no
answer.
idea.
Let me get an answer
When
from
you get
Paul.
deeper.
Does the temperature gradient vary along the length of the island as it gets further and more around the curve, Paul? Yes or no?
It probably does vary, but it
Of
won't
course
change
it does.
much,
It
but
needs
that's
to,
not
Paul.
the
It
point.
must
That
on the
is
globe.
not the
On the
point.
globe, we have to have varying
point is-
degrees of
point is
atmospheric
what this
pressure and
refraction
atmospheric
coefficient
conditions,
comes out to
varying
be,
temperatures.
Nathan.
We've got to have so many things to make this thing curve around the Earth. It's
refraction
untrue.
coefficient comes
Oh,
out
we're going to see that in how many
something
days?
that
How many days do you
allows
need to do the
you
maths on
see
that, Paul? How many days are you going to need to
How
do
the
the
sun's
maths on
lit
that
to a
varying
day.
temperature gradient?
Hey, if you
Right, so
remember
I'm
right,
going to put in
How many
a
maths will?
temperature
How many
gradient
days,
of
Paul, will you
0.
need to do the maths on the
What?
varying temperature gradient along the length of that island? How long will it
So
take?
you don't
you?
like maths, Nathan?
I don't need to.
Yes, you
I
do.
don't
You
need
just
to.
said
Okay.
it probably does vary, and it
I'll
needs
give you-
to
I'll
because
give it
it's
to you that the
it's
temperature gradient
curving
is the
at
same, Nathan.
various
Would you
rates,
be
Paul.
happy, Nathan?
It's
Would you
curving
be
round
happy,
the Earth
Nathan,
because it's
that-
further away at the
that
end
the
of the
temperature is
island
the same?
than it is at the near side of the island. So we need varying degrees of temperature gradient, don't we, Paul?
Oh, you're just
for it
gonna
to
keep
bend it,
galloping along
for it
and
to
not actually
bend in that
what I'm gonna say.
variation. We need varying
Then
degrees
I'm
of temperature
giving
gradient,
you-
don't we, Paul?
I'm giving you that the temperature gradient is the same.
Oh, it's all the same. So how do we have this effect where the far side of the
goodness
island
sakes.
is being
Well-
refracted more around the curve than the near
I'm
side,
asking
Paul?
you, and
How is
then
that
you're
a
not gonna let me
possibility?
tell you.
Don't. Go on then.
Yeah, explain it. Explain it. Blah, blah, blah. No, don't explain it. I don't want to hear that. Explain the curvature. So I try to explain it. No, we don't want to hear that.
Stop using maths.
Is this an explanation
Explain
for
the
how
curvature.
the
Explain
far
how we
side
can
of the
see it.
island?
So
I'll
I try
repeat the
to explain
question.
it. No, we don't want to hear that.
I'll repeat the question for you, Paul.
That's
How
what you're doing.
does
You've repeatedly done it
how
for the last
does
half
the
an hour.
maths account for the far side of the island, the left side,
Right.
that's
Now
50
that
miles
you've
away?
asked the
You're not going to
question,
listen to the question,
are you
are you,
going to
Paul?
let me answer?
I love it. So triggered. Wonderful.
You already
yeah,
got
I
it.
am triggered.
Paul.
Yeah. Your maths has got to do a lot of work here, Paul. A lot of work. And the bit that I'm asking about now is how the... I know everyone's talking over me now while I try and get my question in. How does the maths account for the fact that the far side of the island, the left side that's at 50 miles, is supposed to curve further around the Earth than the near side? Will your maths account for that with this varying temperature gradient that is needed to curve it further
Yes,
or not?
it will.
It will?
Yes, it
How
will.
long are you going to need to put in this
Yes, it
varying
will.
temperature gradient to the maths
And I
as
know-
well, Paul?
yeah,
How long will
I know
that
what you're
take
gonna
you?
do too.
You know nothing about the maths. Don't make assertions that you don't understand, Nathan.
I know I can see
Ask
the
me a
island,
question
Paul.
and you
I
make
don't need to
assertions
know
let
the
him
maths
do
and your
Before
gishgala
I even
to know
do
I
the
can see it
calculation, you
and
make
to know that it's not a
assertion that it won't
mirage.
account for it.
I know what I can see, Paul. And I know it's not a mirage. I know it's not being bent by varying degrees of atmosphere
How do you know?
around the curve, so it
How
comes
do you
back
know?
into perfect view
How do you
and in
know?
perfect proportion.
How
This
do you
is
know?
nonsense, Paul. You're in a
How
fantasy,
do
my
you know?
friend. You're in a fantasy
there's
world
nothing
of spinning globes.
How do you know?
There's
Fantasy,
nothing about
How do you
because
know?
I can see a
There's
picture,
nothing clear
because I've got
about
eyes,
Making
Paul.
assertions
I can see
like,
it. No, I'm not making an
know.
assertion, Paul. I'll tell
How
you
do
how
you
I can know, because I've got a picture of it in perfect proportion. It's not being bent back around the curve in varying degrees. It's
How
just
do
in
you
perfect
know?
proportion. It's as simple as
How
that.
do you know?
Because we can see it.
You can
Not
barely
because
even
of
see the outline
maths,
of the island.
because
Are
we
you
can
crazy?
see it, Paul. That's why I'm not a fantasist. I can see it. You are going to
And yet
maths
we
to
can't
explain
see
why
the
we can
bottom,
see it
and yet
when we
can't
shouldn't.
see all of the
You're
cliff
telling me
under
it's a
that lighthouse,
mirage.
can we?
You're telling me it's bent further around the curve at the back end of the island as the front end of the island, and varying degrees of temperature can bring it back in a greater severity from the far side than the near side. It is the biggest load of nonsense I've ever heard in my entire life.
And
We
the
see all of it.
biggest load of
It's
nonsense
perfectly
is
proportioned.
like
Your
the
maths
Bible
can't
says
account for it.
your
You need
explanation
days,
is what
and you
came
need to
out
go
just
so far
then.
from the accepted standard that your model uses. It's untrue. You need days to account for all of these anomalies.
Would I go ahead,
Listen, there's
Nathan,
one place
and
where
prove
wait,
that it
wait,
is
wait.
so far from the accepted standard?
Yeah.
You made the assertion that it's so far from the accepted standard. Prove it.
Okay, bring up a calculator for non-standard refraction.
Huh?
No, do it without.
Did you not hear my question, Paul? Bring up, like,
Here's the question.
hold on, we're all talking over me. You've just asked me to prove it, now I'm doing it. Bring up a non-standard refraction calculator that the globers all accept.
We want you to do it without the non-standard.
This is the
refraction
non-standard
calculator,
refraction
the way-
No,
calculator.
no, that's a calculator. We've seen several
This
examples
is
from...
the
Hold on,
non-standard
Paul.
refraction
Paul, you
calculator.
just don't seem to like this, do you? We've seen several examples from several people on both sides of the argument where they have a calculator readily available to plug figures in that's available to everybody publicly. this is a calculator that you're putting figures into, Paul. That's very different. Do you have an accepted non-standard refraction calculator that everyone accepts or not?
He's using it right now.
Yes.
He's using a calculator. Are you a moron? Do you want to keep telling me that it's a non-standard refraction calculator, or does it say the word Google calculator at the top? Silence. So, Paul, in your own time, bring up the accepted non-standard refraction calculator that Globers accept.
The super easy one to do.
We seem to be getting lots of silence and interjection, and not Paul bringing up a calculator that's accepted by the Globers.
This is one.
That's a calculator, Paul. I'm not an idiot. I can read. It says it at the top. Do you want me to read the top of your tab?
What? This tab here?
Yeah. Do you see what it says? Does it say non-standard refraction calculator?
Oh, for God's sake.
For God's sake, it's too difficult to find one. I'll do the calculation. I'm the authority on non-standard refraction.
Oh my God.
Oh my
That's the
God.
equation right there.
That has to be the dumbest thing I've ever heard.
So do you not have one?
Up a sec, guys. Nathan, you've got a guest that's come in that's avoided an introduction, and I think he deserves one.
Alexander, my apologies. I
Correct.
didn't see you. Really sorry. Two involved in the debate. Where's Alex when you need him? Sorry, Alex, you're right at this stage. My apologies, Alex.
I joined too, but you know, not much information.
Oh, two involved. Sorry, Josh.
Things.
Oh, it's Chris.
Is my mic okay then? After all,
You can't really hear you, Chris.
oh, right. Okay, I'll play my other mic.
It sounds like your mic's interacting with something else on your computer.
Hold on, man.
So, Nathan, just one small thing. I actually really hate these kind of hangouts where there are more like 3 or 4 people in there. It's just too much chaos for me.
I agree. I prefer it more one-to-one.
I would like to talk to you, to talk with you about refraction in a separate hangout, if that's possible for you. Where I would explain in detail how this equation works.
Because
I'll
I'm
talk
afraid.
with you.
Sorry, Alex. This is it.
I'd like to talk with Geo over refraction in a different hangout. If Nathan doesn't take that up, I'll take that up.
Any better?
Actually, I would like to talk with Nathan about it, because I think he actually understands it less than you do.
I'd like to cite the physics behind the mathematics, though, because the physics.
Yeah, I'm gonna find that out. How exactly the equation was derived from, for example, the ideal gas law and the atmospheric altitude law. I would show that.
I've got 2 MIT papers on refraction that I'd like to talk through, but I've not had a chance, and I've waited patiently for like 25 minutes or whatever. And this is really the physics that I want to talk about, because I want to show how they contradict the maths. And all the maths that Paul's doing may well work out, but I want to show where the maths comes from and how it contradicts itself, and therefore makes the maths null and void. That's really what I wanted to do, because it's the maths that's like icing on the cake. It needs to be justified.
Anthony's going to debunk a physics paper.
Yeah, I'm going to apply a physics paper.
Nathan, could I please get an answer from you? Would you be willing to do that? A 1-versus-1 hangout with me?
No, this is what I do. If you want to do it now, feel free.
All right, then I would like to have no interruptions from somebody. I would like to be guaranteed a few minutes to explain this.
You must be joking. Do you
I
not
am
watch
not.
the show? This is the show. This is how it is. If you want to get your points in and your jabs in, feel free.
Yeah, well, I can't do it when I'm interrupted all the time. That's why I'm inviting you to another one.
Okay.
let him do
No,
it.
that's my answer. This is the platform.
Geo.
This is it. This is it. You're here. You want to tell me something, but you want to tell me in private. No, this is it.
Because it wouldn't. First of all, it wouldn't be in private. It would be streamed on another channel. It could even be streamed on your channel. I don't give a damn. But it would be a hangout where nobody would interrupt anybody, because this is stuff that you need to go into detail about. And when there's some always coming stuff from the sides, it's hard to explain it. And I've seen what you're doing when somebody is trying to explain it.
Well, if Nathan
So
doesn't
it's
take
hard
you
to do
on
it
it,
here.
I'll take you up on it, Alex.
Yeah, sure, Anthony. We could do that. Just give me like two or 3 weeks, because this is literally my last day at home. I'll be going to vacation tomorrow.
Sure.
So like in the beginning of January, maybe around the 10th or so, that would be ideal.
But you're here now. I don't get it.
Yeah, but I've seen what you did to the other guy. Who was it?
Paul.
Was it? Yeah, it was Paul explaining it. And whenever he went into detail, you completely derailed. That's what I'm trying to avoid.
I think the reason for that, and I think it's because it's not right. I'd like to talk about the physics behind it, and given that Paul's a physicist and Alex is also quite up there, why can't we talk about the physics before we get to the maths?
That's what Paul was doing.
No, he wasn't. He was talking about the maths and only the maths.
Are you joking?
You wouldn't let me talk.
No,
about
I am
the
absolutely
physics. You got to be
serious.
joking.
That equation
Paul was talking about the
I was trying to explain the physics, and you guys wouldn't let me.
You were explaining
you
mathematics,
kept on
Paul.
interjecting in.
Paul,
No, I was trying to
maths.
explain the physical phenomenon behind that.
Paul,
I took physics in high school.
We're talking about equations, mathematics, and how they apply. I want to talk about why, not how. Why? You're a physicist. Why can't we do the physics?
I was trying to tell, and I was
Paul
trying
explain
to
this to
tell
you
you why,
yesterday, though?
Anthony, and you kept on acting like an ass and
I
interrupting.
didn't, Paul. I kept quiet.
That was me, Paul. I was doing it
Nathan
deliberately
did.
just to troll you. Sorry. That's just
Why
fun.
can't we talk about the physics?
I tried to talk about the physics. You guys wouldn't let me.
You didn't do physics.
And Paul did it yesterday to you, Anthony. Don't say he didn't, because Paul did. He went on in depth on it yesterday.
We never touched the physics yesterday.
How long will your presentation
nonsense.
take, Anthony, approximately?
Well, 10 minutes max.
You can try.
I just don't understand why we have to go to the maths before we consider the physics. And Paul's a physicist.
That's because you don't understand anything.
I can't
Fair
believe
game. I'm allowed to interrupt you now, aren't I, Anthony?
I'm going to step out, gents, because there's no real discussion or debate here. It's just Paul talking about maths.
That's right.
I'm not interested in maths. And I'm going to run away because, and when you're ready, Paul, look me up and let's do a private hangout because I want to challenge you on your application of physics, not your maths, your physics, because that's your expertise. I don't want to talk about the maths until
before you go
from the physics, Anthony.
Well, let's
Paul,
see if we can get a consensus,
look me
because we've
up.
had Alex, the voice of reason, say, look, this isn't a cordial platform to do a debate, which is what we've got here. Oh, he's gone anyway. Oh, well, that was a last-ditch attempt to keep him here, Paul. Sorry.
I mean, to
He's
say that,
blaming me now.
Paul, to say that Anthony, you didn't show Anthony in depth yesterday is a little bit crazy. I mean, you went through the whole thing. And we found out that he does not know what the 7-6 means. That was uncovered. So what is he talking about? He's going to debunk the physics. Like, we found out yesterday he doesn't know what the physics are. He doesn't understand
He
it.
has no idea what the physics is.
My physics teacher was the football coach, and he made the class really easy so his players could pass.
Now that Anthony's run like a little rabbit, I'm actually going to explain for the people that may still be watching how this calculation actually works. I'm going to do that number again. So we start with the 503, right? So we start with the 503. We multiply it by atmospheric pressure. Now, he said it was a nice day, so we will take that as 1,030 millibars. That seems like a reasonable thing to do. I've looked up the temperature of the day at St. Bees, and it was no higher than 13.6 degrees in all of October. So Anthony trying to claim yesterday that it was 30 degrees in St. Bees is laughable. So I'm going to use 13 degrees, the highest temperature almost. So 13 degrees works out to be 286 degrees Kelvin. So we have to divide by 286 degrees and then divide it by 286 degrees Kelvin again. And then we have to multiply it by this factor, which is the 0.0343, and then we have to work out what this temperature gradient is. The air temperature being 3 degrees Celsius higher than the water temperature means that we have a temperature inversion because the temperature of the air next to the water will be colder. Okay, and so as we rise up above the water level for a short distance, the temperature will go higher before it starts to then decrease again as we get back into the standard atmosphere, okay, well above the water. I'm taking only a 1 degree Celsius gradation in temperature over 20 meters. And I think that's quite a reasonable thing to ask. If you do 1 in 20, that's 0.05. And because it's a positive temperature gradient, we are getting hotter, we have to add that here, right? So we now have to add 0.05 on that. And that number comes out to be 0.5339. I'm going to write that down. 0.5339. Now what we do is we take that value of K and we put it into here, into the
Paul, you're just here for
radius.
distraction. What does this have to do with flat Earth? You're talking about everything but the flat Earth. What does this have to do with flat Earth? How does this prove the shape of the...
What this explains is how the rays bend.
You're just wasting time. You repeated the same thing all week.
No, I'm not. Let me do the calculation. Okay.
Are you trying to? Who are you trying to get through to?
What we do?
Yeah.
I'm trying to show
wasting.
you why.
You're wasting time.
At the end, Spurs, he'll tell us that this is how the maths shows that we're not really seeing it because it's hidden by the curve. We're actually seeing a mirage that's been bent around the curve.
So you're going to do
here's the maths to prove it. We're not really seeing it, Spurs, and he needs to explain it away with maths.
We put in the radius
of the Earth here, which is 6,371, 6,371, and we divide that by. I'm trying to go quick so you can get it done. None of us are listening.
And
it's
then
just
I subtract
boring.
that number I had
we see
before,
the island,
which
Paul.
I
We've
wrote
gone through
down,
this. We've had Alex tell me off for saying, "No, you don't understand the maths either." But I don't care when I can see something, and you're telling me it's a mirage.
I know you don't care, Nathan.
No, don't.
I know you don't
You're
care.
right.
You
I
don't give a crap.
You want to explain away why I can see something with maths?
You're just taking.
We get an effective
dogma.
radius.
This is dogma.
We get an
This is
effective
dogma.
radius
Paul.
of
Look up the word dogma, Paul. This is what dogma is.
With your explanation, we don't keep moving on to the next
Dogmatist.
step. Why are we always stuck on your point?
You're going to do it again because you keep
don't seem to
interrupting.
make
That's
any
why we
ground
start.
for
You've had ages.
Why do
You've
we
had
make
ages,
any
and it's
ground?
getting boring.
Because
You've had ages and ages to do it, and what you're never going to do is explain it away with maths. You're not going to explain why we see something that we shouldn't see.
Ignore.
I'm more interested in why.
So now what we do
doesn't move forward to the next point. Why don't we always say, I get it? Why do we keep going around?
This is never going to reach a point, Spurs,
So
where
here
when
is
we
the next
see this
point.
picture, we go,
What we
oh, no,
do
I get
on
it
the
now.
next-
I'm not really seeing it. It's being bent around the curve that's in the way. No one's ever going to look at that picture and go, oh, yeah, that makes sense, especially when the far side of the island's considerably further away than the near side. That's the bottom line. There you go, Alex. You've got your chance. Looks like a sniper has kicked a load of people out. Oh, maybe they've been kicked out as well. Time for a new hangout. Fun. Literally left all on my todders. I'm the only one who's not sniperable. So I may as well run through my links as I start up a new hangout. If you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate, there is a link that will be shortly placed in the info box below this video. With the page you are currently listening to me do this announcement on muted, simply click that link to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcome back on the next stream. In a moment, I'm going to transition back to the Hangout as I've got the next Hangout running, and I'll stick the link in the chat if anyone wants to join from there. Good show so far. Let's see who we get back. I might stick it in the info box as well in case anybody's looking for it there. There we go. So the link is now in the info box. I'll encourage everyone who's watching this live stream to please share the show, as it does increase that live audience, which in turn increases the chances of a more diverse panel. So please share the show. Been joined by Chris and Alexander. How are you doing?
Can you hear me?
We can. Hooray!
I can hear myself. Second.
Ranty with us. Be a few minutes for the audience while we get a few of our guests back. Snipers aren't as successful in terms of ending a show as they used to be. I think that was about, my link takes about 120 seconds, so new hangout running and new guests in within seconds. Pete's here, good to have you, Pete.
Still pretty annoying though, they should do something against that.
They want it, it's good entertainment. YouTube want entertainment, so that's what they want.
I don't think they want the snipers.
No.
Definitely
I
not.
just stopped by to just do a measurement from the side of the Isle of Man to where the filming location was, because there's a rumour going around that it's only 50 kilometres, and I just want to put that to rest, and then I'll step out.
Yeah, you're presenting, Ranty.
Am I? Okay. Right, okay. So all I'm just going to do is put a ruler in here just to show you, and everyone in chat.
I have two.
Sorry?
I have two icons. What's going on there?
Welcome back, Paul.
Yeah, carry on, Ranty.
Yeah, it's literally just a ruler measurement just to the side of this island here. This is the left-hand side of the island, and as you can see, 50.69 miles. So that's it. So I'm just putting that to rest because there's a rumor going around that it was kilometers. So hopefully that's addressed the situation now.
I think it was Paul that
I was measuring
kilometers.
to Moorhole Lighthouse, not that point, because that's what I was focusing on.
All right. Well, I'm talking about the entirety of what was actually videoed. So to the far left-hand side of the composite is 50 miles away. So there you go. So I'm just going to step out now anyway. Leave you guys to it.
About half an hour left on this stream, providing we don't all get sniped by Pete Shea, who joined a second ago.
Yeah. I'm not sure at what point in my explanation I dropped out. The point that I was trying to make, I'm trying to find that Metabunk site again that I had the calculation up on. The point that I was making was that we had about 113 meters that feet that we had to account for that was missing in that. Yeah, this is the image. That's where the lighthouse is. So I'm going to try and zoom in on this again.
You're not screen sharing at the moment, Paul.
Yeah, I've just got to get the image in the lighthouse, and then I'll share it. Okay, I'm just because I had to zoom in on it all again. I've got to find where that lighthouse is.
Yeah, but Paul, you're just regurgitating what you've been told. None of this that you've studied yourself, you've tested for yourself.
I've got it.
Welcome back, Tony.
Okay, I'm about to share it again.
Hey.
So using that refraction calculation, which all I was asking was 1 degree Celsius over 20 meters above the water temperature gradient accounts for this refraction. We can clearly see here the lighthouse. The lighthouse was 75 feet. The distance to the from the top of the lighthouse to the seafloor, 213 feet. If that's 75 feet, from approximately there up to the top of the lighthouse, then it's quite reasonable that we're looking at about another 25 feet below that lighthouse before we get to that horizon, and there's about another 113 feet below. So
I don't
simply by using a 1 degree Celsius temperature gradient,
I think you missed the beginning of the part of this hangout
above water for 20 meters and nothing else, except the temperature of the day.
You're making an assertion because you didn't watch the beginning part of the hangout.
Yeah, I completely disagree.
You didn't watch the beginning part of the hangout, Paul, where I think it was Anthony that explained the view that you're getting of the lighthouse is slightly. Well, you'd have to watch the beginning of the hangout. It actually brings up a photo.
I know what the view of the lighthouse is.
Okay.
It makes no difference.
Well, it does because it shows that the water line goes up to approximately.
I can bring up Because what?
You're not really letting me finish. Either you have seen the beginning of the hangout or you haven't. At the beginning of the hangout, he shows that the water line brings it to such that you have about the same height of the lighthouse again in terms of the actual lighthouse.
No, I saw the way that
finished,
Anthony
Paul.
did that, and that was
accusing me of talking over you and being rude, and now you're literally talking over me.
Because he was doing it.
So you don't seem to be wanting to listen to what I'm saying. So at the beginning of the hangout, he explained.
Well,
I'll try and get through all of it without you interrupting me, Paul. As you criticise me for doing this, I've stopped doing it, and now you're doing it to me. So at the beginning of the hangout, he points out.
Are you surprised?
Oh no, I got about 3 words in. We got to, at the beginning of the hangout. It was illustrated that the water line leaves it such that the lighthouse is approximately its own distance again between it and the water line, because there is an extra building in front of the lighthouse that sits slightly lower and creates the impression that the lighthouse, with its measurement that you went and got from Wiki or wherever, makes it seem like it's bigger. Therefore, it looks like it's further down the coast, and the coastline comes up considerably higher than some photographs, and that's depicted with the waterline shown. This may be done by Ranty at another time to give it more expansion on that. I'm giving it third hand from his explanation to me, but it was clear. We have one height of the lighthouse below the lighthouse between it and the waterline, and I'm pretty sure on a future hangout it will be argued that we can see all the way to the waterline.
And I saw the way that Anthony, I saw the way that Anthony did that measurement, and it was wrong. Right, the way that he cut and pasted that second lighthouse and put it in front of the first one is not the way that you take that measurement. That's
I probably agree with you.
Garbage.
When I saw that image for the first time last night, okay, I said the same thing, if I'm honest with you, Paul. It isn't a great depiction. They have better ones. Yeah, I'm sure they will present them.
It's not, because the angle is looking down on it.
I agree.
That is not a valid way to judge that there's one lighthouse distance there.
My criticism was the same as yours, Paul.
So
I agree entirely.
We know from real measurements and real data that the lighthouse is 213 meters above. Okay, none of this looking down at an angle rubbish. Okay, we are looking horizontal along the water here. We're looking at right angles to the lighthouse.
You can stick your mark by this now if you like, Paul. But...
So we expect to see the full length. Okay.
Okay.
We expect to see 75 feet of lighthouse with approximately 130 odd feet of cliff and other stuff down to the sea. Okay. And we don't see that here.
Okay, Paul, can I now ask my question?
And I've shown you...
before you go on and reiterate it and tell us what you've shown, Paul, you've got to the end of your point, Paul. I've let you get all the way to the end. Now I'm going to ask you a question, which was the same question when we all got talking over me. We'll see if the same thing happens. So you've just said that there has to be a temperature difference in order for this to be brought back around the curve at this distance, correct? Right. At the far end, the far left-hand side of the island, it is considerably further behind the curve. So are you postulating that we have an increase in temperature variant as we go from right to left?
Not at all. What I'm saying is that...
No, is that a no? Sorry, hold on. Is that a no? We definitely don't have a pressure...
Let me answer.
Just want a yes or a no. So there's no temperature variant as we go further left in this shot. We're going to stick with the same maths for all of it.
Yes, that's right.
Okay.
That's the crux of it.
So what's your question?
Yeah.
Well, when we're applying the maths for bringing these items back from beyond the curve, I will hold you to that when we're doing it for the... Get off the iPad. Don't stand on that. When we're doing it for the far side of the island,
how much
Paul,
would you expect? How much would you expect?
Hold on,
to be
you're asking me, and I'm now telling you. So if you're saying that the variant in temperature, which brings it back from beyond the curve, is now fixed, the maths won't change. When we go further up the island and it's being refracted more, then I will ask you to plug the same temperature into those maths.
Let's do it. Let's put in, what distance do you want to put in, Nathan? 50 miles?
Sure.
51, 52, 53 miles? What
Sure.
distance?
50.
50. 50 miles. Okay. Here we go. 50 miles. We've put in 50 miles in here. We've still got the same viewer height of 45 feet.
35
how much
feet.
do we expect?
30, hold on, Paul. You did this
we
last
only
time.
expect
35 feet, Paul. 35.
Beg your pardon?
Put in 30. I think you've put in 45.
Hey, thanks for welcoming me to the show. Check out this screen thing I'm sharing here.
Viewer height, Paul. 35.
Check it out. Check it out.
What we got here, Lewis?
You really think that's 35 feet, Nathan?
So I'm just asking like Paul something. Feet. Sorry, the adults are talking.
That's a minimum of 100 feet.
Irrespective
Look how big those people are.
We have an incorrect viewer height, but regardless, we have a hidden.
No, that's not regardless.
Refracted.
That needs to be regarded.
It seems we've got a troll who wants to troll me now.
This whole video.
Now we've got to the calculation that we didn't. Jem didn't want to bring up yesterday. We can see that the 20 feet of land. No, it's 20 meters, isn't it? Sorry. Can you? Any chance you can put this in metric?
Do you guys ever notice Lewis looks like Sigourney Weaver?
Right, so we've got refracted hidden at 111 meters, and we've got 20 meters of land on the far left side. Right, so we're going to have to do.
And my
more...
contention would be that I'm not sure that we're actually seeing.
Sorry, I'd finished, Paul. Okay, clearly I'd finished. I'll just go on mute, Paul. You just take the floor indefinitely.
I mean, he's qualified to, and you're not, Nathan. So.
Well, he's also qualified to put up an equation that shows that we have a refractive hidden of 111 meters with his fudged figures.
I mean,
sorry, I just addressing Lou now, Paul.
I mean, you guys.
So he's qualified to show me that we have a refractive hidden distance of 111 meters, and yet we're seeing something that's 20 meters. And it's I'm being trolled now. Being trolled by the globeheads now. We're at the point where we actually have some maths that shows us how much we shouldn't see. How much we shouldn't see, and now we have to go on to how we have mirages bringing it back in. Mirages. That's what we're seeing. Mirage.
I don't. Well, I mean, what you really, what you really need
that
to
Anthony
look.
lied about this. The viewer thing. That
Yeah.
Said extra 75 feet.
We're lying about the viewer height now. Well, we've already fudged it on that example.
That's
it was 45
right.
and
The
not
viewer height
35.
is obviously not 35 feet. And anyone who thinks that it is 35
feet
is severely mistaken and absolute
move the goalposts, change the viewer height. Do anything you can to bring it back into view when we can see it already.
Refraction does that, and what needs to be explained is how Anthony Riley thinks that the dimensions of the Isle of Man are what they are. That needs to be explained as well. I'm going to bring up his original video and go over some of the initial points made in it.
He's got his dimensions from what we're looking at now. Why would he have it wrong? I don't really understand why you would assume that he's got the dimensions wrong when we're literally
because I'm looking at the video, original video, and he gets them wrong in that video. So that's where my assumptions come from.
While he's on the beach filming, you're saying he hasn't got this what we have in front of us while he's on the beach with his P900. Is that your criticism, really?
Let's go watch his video, yeah?
So that is your criticism, that while he's filming it on the beach, he gets one of the measurements wrong.
Yeah?
That's your criticism, is it?
Let's watch his video, yeah?
Yeah, no, I get it. Your criticism is while he's filming it, he gets one of the measurements wrong.
Rather than trying to
There's a word for that. It's called being pedantic.
No, pedantic is when you just split hairs about the definitions of words. All right, so let's go to where he says the Isle of Man ends, which is right here. That's not true. It doesn't end there. It continues on to over here as well. He thinks that this is Scotland. It's not Scotland. It's the Isle of Man. There's a whole bunch of missing land here. Where is it, Nathan?
And the fact you can barely see it anyways.
Why can't we see this land, Nathan? Is it maybe because there's curvature?
She's an Isle of Man, baby.
Man.
P. Mars, you should continue to never speak.
Yeah, let Lewis labour this crappy little point that he thinks he's got.
This
is what I was thinking.
It's a game ender for Anthony's argument here, Nathan. Yeah, what is this land here? This is the Isle of Man.
See if the guy who took the photo can answer you, Lou, without you interrupting him.
I have never once suggested or asserted that that was Scotland. My position is
let's go to the part in the video where you do exactly that.
Right. Let's see it.
First of all, this is taken at low tide. That should be noted. How do I know it's taken at low tide? Well, there are images on Google Earth where these piers right here have the water butting up right to them, and you can tell that that frequently happens because there's water here and there's the water stain here, and that's where the fine sand grains are. The rough
tide
sand
height was
grains
3 meters.
are further back up here, suggesting that this
Lewis,
is frequently
show
washed
the point
by
where
the
I said it was
tides.
Scotland.
I will get right there. Don't you worry about it.
Tide height was 3 meters.
And we can get here. We see where you were standing from relative to these buildings. Now, this distance.
Sorry, are we going to get to the part where he says it's Scotland?
Up to the front of the beach
We're
is
gonna get to the part
probably
where he says it's
35
Scotland,
feet.
Lou? Or are
The
you just gonna
difference
make
in
a new
elevation.
assertion? I've got to interrupt you, Lou. You've made an
Calm
assertion,
down,
and
I
now
will
you seem
get
to be
there.
distracting from it. Are you going to
The
show us the
distance
part
from
where he
here
says it's
to here
Scotland?
is probably 35 feet.
Yeah,
and
are we going to
right
get to the
there,
part where he says
just
it's
this,
Scotland, Lou?
Just this.
Do we
is
get to
probably
call you a
35
liar at
feet.
the end of
You
this,
have
Lou,
another
or not?
70 feet to go at least to where
Anyway,
you're standing
back to
up
him
here.
asserting that it's
Look at
Scotland
the height
in
of
your
these
mind,
buildings.
Lou.
Look at
Lou,
the height of this cliff
let's keep
face
you on
that
track,
you're
my
standing.
friend. Lou, Scotland. Do you remember? Do you remember you asserted that?
Yeah, I'm getting there, Nathan. Don't you worry.
Get there a bit quicker.
Don't you worry. I will get there. There's so much crap flying off the screen in this video.
And the viewer height is absolutely
the most
essential.
important part.
You can't just skip
there
by
she
it like
is.
you're trying to, Nathan.
There she
The
is.
fact is,
He's saying about 20 claims in 4
Hold
seconds.
on, Jem's always good for a good laugh. Let Jem have the
How can
mic.
you
Jem's
do
good for a laugh. Jem's really angry
The
about
Isle
this
of Man
situation.
does not stop here.
If
It
you
does
look,
not
really
stop
does in
here.
the evidence. If you look
The
at
Isle of Man continues on underneath the horizon.
If you look
Oh,
at
Mike.
What the hell is
funny.
this? What the hell is this? Oh, that is the actual end of the Isle of Man. And well, I mean, this over here is, but this is the far end of the Isle of Man, the far north end.
Where's
It's
the
not
point I said it was
Scotland.
Scotland?
And the fact that you post a question postulating that it could be Scotland is
Where's that?
ridiculous. And
We haven't seen
let's
that.
look at the title
Where's
of your
that?
video.
Scotland.
Where's that? Where's that, Lou?
Oh, I'm sorry. Ireland.
Ireland. Yeah. Okay.
So
Big deal.
What an idiot! What an
Let's-
idiot! Are you
let's
that
keep going.
geographically
Oh, what's
challenged,
is that a
Lou?
building?
What
Is that a building?
moron!
No, it's not a building.
What an
That's probably-
idiot! What
That's
an
probably very,
idiot!
Anthony.
Idiot!
Not
What a
a building.
complete idiot!
So have I
He-
made
Yeah,
he made a mistake about
I'm the
Scotland,
idiot.
Ireland.
I'm the idiot when he thought that viewer height was 35 feet.
So we're
It's like
moving on from
35
Scotland then.
meters.
Moving on from Scotland, Lou, you moron.
Yeah, he's
So
talking
did I
about
mention
Scotland.
Scotland,
They're
Lewis?
actually hung up on you.
Did he
Sorry
mention
that I don't
Scotland?
live in the UK and have a familiar.
So you're a moron. So you're
Scotland.
geographically challenged
Look,
as well, are you? So
important
you're a
thing here
geographically
is that
challenged
it's the Isle
moron.
of Man.
You're a
It's clear
geographically
that
challenged
credit
moron.
that for you
Okay,
to say
geographically
Scotland is a
challenged
big deal.
moron. I think the
He
thing you
meant
should bring to
Ireland.
this
See this
debate
here?
is silence,
He
like
meant Ireland.
you told P. Mars.
This
I
is
think the thing
all-
you should bring
this
is
is all
silence
the
because you're a
Isle of
moron.
Man.
You're a
All of this
geographically
is the
challenged
Isle of
moron.
Man.
That's your problem, Lou.
All
How many
of
times do you need me
this-
to point out this
Nathan,
geographically
Nathan,
challenged problem that you have?
Nathan.
Moron.
Is that
All
correct,
of it.
Anthony? Is that all the Isle
All
of
of
Man
this
is? What
is
he's
the Isle
You
of
should
Man.
bring silence to
Island
this
is the Island.
conversation, Lou, because you're a
All of
moron.
this
Yeah,
is
but
the
Anthony,
Isle
is
of
that
Man.
correct? What Lewis is saying? That's the Isle of Man.
All of this is the Isle of Man, and it's also over here on the left too, right there.
Yep.
All
All right,
of
Lewis. Lewis.
this whole thing,
Lewis.
the whole thing. Oh, unexpected starts here. Is it Scotland? Oh, maybe that's where I got the idea that might be
there
Scotland,
it is.
Anthony.
Oh,
Maybe that's
now,
where, from
Nathan,
your own
maybe
video. Am I
apologize,
still a
Nathan.
moron? You probably still think so, but that's because you're all morons.
Lewis, we need an apology from Nathan, please.
Yeah, we're not going to get one. Nathan doesn't do
He
apologies.
just talked
He's an
shit.
idiot.
He was just talking shit. Oh, idiot! He said Scotland.
All right. This
Question
entire
mark,
thing,
question mark,
this
question
entire thing is the Isle of Man.
Yeah, Lewis, you're forgetting the question mark.
And this
I
Yeah,
said,
question
I
mark.
said question mark. It's still. I said it was a postulation.
And
No, you
this
said I
entire
said
conversation
I
is
thought it was
basically a
Scotland.
result of Anthony's lie
Yeah,
about
all
how
of this
high he
all
was.
theory, whether
He's
it's
clearly
all
Look at
of
this.
that.
well
Look at this.
35
You
feet.
think this is 35 feet? You're insane. The first thing Paul said was that's at least 60 feet, and that's being extremely generous.
Yeah, Lou lied
Go
about
to
it
the
being
same point on
Scotland
Google
in
Earth.
his mind because he's geographically challenged and an idiot.
Well,
liar.
I mean,
Liar, Lou.
if
You
you
lied. You
think
got it on
I'm
camera, Lou. You got it
geographically
live.
challenged, I mean,
Lies.
let's
Just
go back
lies.
here. Do you think that this
I
is
know.
Scotland?
Terrible, isn't it? How these horrible globers
What,
lie
do you,
so
do
much.
you think this is
Can
part
I
of the
show
Isle of
you?
Man?
Can I
Lies.
show another view of this beach?
Do you think this is the Isle of Man? Yeah, you can do whatever you want, Jim.
You think it's Scotland? You're a moron.
He's the one who asked. I
Anthony's
mean,
the one that
yeah.
said it.
I mean, what does this say right here? Unexpected
says
land
right there on
starts
his
here. That's not
screen.
unexpected. That's
Scotland.
highly expected. Anthony's the one
No,
that's
it's not
asking
highly
if it's
expected.
Scotland, Nathan. Do you want to
It
direct
isn't
your
highly
insults to
expected at all.
maybe
Don't be
Anthony?
ridiculous.
Anthony, yeah, please.
All that land is supposed to be behind the curvature of the Earth. If you go back to the
No, it's not.
Google Earth,
Only
yes, it
the
is.
land that is
Yes,
behind the
Lewis,
curvature of
it
the Earth
is.
is supposed to be
All
behind
of
the
that
curvature of
land
the Earth.
is behind
And
the curve
Anthony,
of the Earth.
Anthony, do you think that you're 35 feet?
Do I think my 35 feet what?
Do you think you're 35 feet in elevation when you took this?
Yes, that's what it says on Google Earth.
Oh,
Right.
let's take a look at this photo here. Do you think that this is 35 feet?
Right.
Above the surface of the water?
Where else would I be talking about?
Right, that's been taken from the mountain that's to the right of the image, and that's really high.
Do you see this photo? Is that where you are standing?
I need to make it bigger. Hang on, let me see.
That is where you were standing. And there's no way that that is 35 feet. Look at the size of the people.
Yeah, and the fact you knew that too, and you knew that, and you
Yes,
still came
and
to 35.
you did know that because that's why you used the words in your video. According to Google Earth, this is 35 feet.
Yep.
You know
Well, what would
full
you like
well
me to
you're
do?
higher
Would you
than
like me
that.
to make it up?
And if you look on Google Earth, it actually has a disclaimer about the inaccuracy of the altitude measurements.
What
The
value would you
elevation
like me to put to it,
measurements.
Jem? One that I randomly make up like Paul
The
does?
scanning resolution they use is a big, it's like a 90-meter scan. So it's fairly
So-
inaccurate.
You tell me, what would you like me to do? Would you like me to make it up?
Lewis, good work, by the way. This was great.
Yeah,
Well, what would you like me to do?
You
Would
lied,
you like me to
Anthony.
use a figure
I
that's
knew
not
he was
on the
lying
map?
too the whole time. I knew it. Well,
And
he was
you,
already
Nathan, you chucked in with a bunch of liars.
Right.
what happened.
What would
Go
you
on,
like
Jem.
me to do
Tell
with
me
the
all
value of
about
the
it.
height?
Tell me all about it, Jem.
We don't need to tell you all about it, Nathan. You
tell us
already
that's
know.
35 feet, Nathan. You tell us that's. Go on, you commit to it.
He's just
Let's
asking
hear
to say
it.
where
That's
he's
35
told you where
feet.
he's got the value from, Jem. Now you tell him where he should get the
And the
value
value-
from.
Maybe
on
he
the
should get the
source.
value from real life.
The value
Maybe
is from
that's
the
Hold on, Lou.
source,
Jem's
which
much more
tells
entertaining than you.
it's inaccurate and can't be used for these sort of measurements. That's where
Jem,
the
we
value
gave you
comes
100
from.
feet.
So
and
in
it
other
still
words,
didn't
he gave
account
the
for it.
measurement
But
and
you
gave
tell
a
us-
disclaimer.
but you
What more
tell
do you
me,
want?
In your judgment, Nathan,
bit higher
this is
pitched.
35 feet. we're looking at.
judgment.
Remember,
Jeremy,
he stood on that cliff.
We gave
looking
you
down,
100
too.
feet and it still didn't account for the missing curvature.
Pathetic.
It does.
You're a liar. You're a
does.
liar.
Yes, it does.
Did
We
you hear that,
gave you
Jem?
100 feet.
Just get an acknowledgement out of Jem, see if we can get him any higher pitched.
Let's get an acknowledgement out of you guys for being retarded.
No,
Yeah, the
he's
whole
given his
Scotland
measurement, he's
At
told where he's
best-
got it
at
from,
best,
and he's given a
Nathan,
disclaimer for what
Nathan,
you are
let's
quibbling
get-
about
let's
here.
Get something straight here. Let's get something straight here, Nathan. Best
really
case
angry.
scenario,
Great
you guys
picture.
are retarded.
You look really
Best
angry.
case scenario.
You look
You
really
picked the
angry.
wrong horse.
Lewis,
What's
do
making
you
you so
understand?
angry, Lou?
Lewis, do you understand that we gave Jeremy 100 feet?
Oh. Best case scenario, you guys are retarded.
Do you understand that we gave Jeremy 100 feet?
I've done the
It might have
calculation
been 80.
myself.
I think it might have
Anthony.
been
I've looked
80.
at the White House myself. Jeremy Wartnaby gave it to you. He did it all yesterday. Paul, the
We
first
gave
time he
him
saw all of this,
100
he gave
feet.
all of you this stuff the first time. He said that's not a different
gave you
unknown
100
landmass.
feet in
That's the
height.
rest of the Isle of Man.
How do you respond,
That,
Lewis?
your observer height is clearly not
Can't respond
35
to
feet.
that.
It's at 60. All of those things were mentioned to you the first time. Best case
Lewis,
scenario,
answer that
you
one
guys
question.
are retarded.
He's not heard it. He doesn't like it. He can't
Lewis,
listen to
answer
it.
the one question
I
we
don't
gave
care
him. It was
what
either
he's-
80
I
or
mean, if
100
he's not
feet.
listening, that's his problem.
Lewis, we did the maths based on 60, and then we put it up to either 80 or 100. I can't remember specifically which. Which
And
value.
what happens when you go up a little bit above 100, which minimum
They want
observer
more.
height there?
You start looking behind the curve of the Earth that doesn't
You
exist
said
in your model.
35 feet.
That's what
I think
starts
you
happening.
got the units wrong.
Yeah.
No, no, no.
That's
We
more like
didn't get the units
35
wrong. We
meters.
applied
And
your
Nathan
maths.
adamantly said, no, don't give him the extra. Make it 35. The calculation was 35. Go back and look at the video.
And if
Yeah,
you,
that's
if
right.
you have,
You said
Because
no. Why
well,
would
if
we
you
give
have
them the
refraction
extra
in there
30
too,
feet?
there is no
you have to
need.
take the tide
If you have
height off.
refraction, there is nothing to misunderstand.
No, there's everything to
The
misunderstand.
missing
We
the
went off
missing
your
land beneath
model,
the
applied
curvature
your
is
maths, and it did not
entirely
do what your
expected.
maths is telling us will do. So what would you like us to
I mean,
do,
you
Lewis?
guys use that word. You guys use the word maths. I don't think you've ever done maths in your life. All right.
What would you
Have
like
a
us
nice
to do
day,
with the
guys.
value of
Best case
the observer
scenario,
height,
you're
Lewis?
retarded.
You tell me what figure you would like me to put in the figure.
He's run
We'll do
away.
it.
He's already run away.
Doesn't matter.
So
The rest of your video is all trash.
So Tony,
maybe it is
now we've
trash.
got you here, Tony. Did you read
Yeah,
my
you
comment?
got me here.
Did you read my comment earlier this morning, Tony? I said once I got you here, I would ask you why your model doesn't account for the missing curvature between us and the Isle of Man. I'd like to hear your answer, please.
I don't trust any of this footage at all. I don't trust Anthony, his footage, everything he says about the footage, because most of his evidence turns out to be, after time goes by, BS.
So your answer for the missing curvature
You guys
is
are
you
lying.
don't trust the footage.
I don't
Okay,
trust any
I'll
of
add it to
and
the
plus
list
it's
of
such a
shitty
bad
excuses.
Video too. It's
No
such a bad
problem.
video.
I'll add
It's
it
such
to
a
the
bad
list.
picture. You can't even see the actual houses you guys are talking about. We had to find the lighthouse for you guys, and then it's not on the bluff.
I guess the point is moot, really, because Miles Davis is actually going to go to St. Bees and take his video camera and do a proper video.
Great. I would
of
love
the Isle
Miles
of Man
Davis
from
to do
St.
that.
Bees. Yeah, he's
He
actually
can't
going
sound
to
his
do
camera.
it properly.
And the measurements.
Wasn't Miles Davis a heroin
Let me
addict?
let me state my position. I was there for a full week, and I only had one decent day of weather. Okay, all the other days were average.
Okay, so we'll see what
2
Lewis
days
does.
rain.
Or we'll see what
So-
he does then.
Well, unless he's going to spend some significant time up there, he's just going to come back with average weather conditions, and he's not going to get anything useful because it's quite wet at the minute. It's winter.
That's right. Paul's going to figure out how to plug clarity into the refraction calculation.
And we did actually show that refraction can account for it.
Yeah,
that was
mathematically,
yesterday.
yeah, but not evidentially.
Yeah, it only takes 1 degree Celsius over 20 meters to
All right,
account.
Paul, I want to ask you a
entirely for
straightforward
it.
question, and you're not
And
going to
that's
be able
being-
to answer
and
it
that's
now.
being conservative.
Paul, I want to ask you one question, and you don't have to answer it now. It's going to take you time to go back and be able to research it. But can you tell me why Fermat's principle of maths on the trajectory of light is not being applied? You don't have to answer it now, but I want you to think about it specifically. Why is Fermat's principle on the trajectory of light not being addressed?
Do you know
We know
what
what
Fermat's
Anthony just
principle is?
Googled.
I do.
Do you know what Fermat's principle is, Anthony? Would
I
you
do.
like to explain Fermat's principle to us, please?
No,
Yes, I
I'd
would
like
like to
you
hear
to
it.
tell me why it's not being applied.
What is it?
What is it? What is it,
I'd
Anthony?
like- I'm not
What
telling
is
you now. I
Fermat's
want you to
principle?
come back with the answer to the question. Why
No,
is Fermat's principle on the trajectory of light
You
not
want me
being
to
applied?
explain whether or not it's been applied. Tell me, what is Fermat's principle?
No, I want you to go and look it up, Paul.
No, I want you
go
to
and
tell
do
me what it is.
Physics.
See,
I want you to go and
I
do
want
the physics
to know
and tell
that
me
you
why it's
understand
not being
what
applied.
Fermat's principle is.
See,
You're
everyone.
bringing it to the table, Anthony.
I am bringing
want
it to the
you
table, and I
understand
don't
what
expect
it
an
is.
answer immediately. When you've got an answer, then we can have the discussion.
Well, you're the one bringing it to the table, Anthony.
Yeah.
That's right.
Surely you,
But
surely you
there
understand
would be
what
no
it is
point in
you're
talking
bringing
to
to
you
the
until
table.
you know what you're talking about. And until that point, there is no discussion. But I want to know the answer
So
to the
his
question.
credibility is the one at question here, not yours?
No,
Since when?
not his credibility. I'm asking about the science. Why does Fermat's principle on the trajectory of light not be the discussion point? Why are we talking about the atmospheric conditions?
What is Fermat's principle, Anthony?
Yeah. Just because you read it on wherever you got this from, and you thought it would be a humdinger of a question, you have to
No.
you have to at least explain that you understand it.
I'm
Then
not prepared to
he
explain
can
it
do
until Paul's looked into it. Because when he's looked into it, then he's speaking from a position where he's got
He
something
knows
to
it
say.
already.
Until he looks into it, I'm not going to discuss it. But next time we speak, Paul, I'm going to ask you the question again, and then I want you to give me a clear and concise answer for why Fermat's principle on the trajectory of light is not being discussed.
And with that, I'm going to say, first and foremost, a huge, massive, enormous thank you to all of the live audience for watching and sharing this debate. And of course, a massive thank you for the patience of the debating panel for putting up with all the sniping, and of course for making this debate possible. Be sure to like, comment, share and subscribe. I've been Nathan Oakley, and I'll see you all in the next video.